So I just personally, I know my students are maybe a little bit too young for Wolfenstein, but for me, Wolfenstein 3D came out when I was 10 years old, and man, I played that all the time. So it's a great thrill to be able to finally meet the man behind it, and also many hours of my middle and high school years went to playing Doom. Such pioneering efforts and very realistic first-person shooter, the first real use of network multiplayer games on a successful scale. And then now, if you've been reading the news at all, you know his current company, Oculus VR, that John is CTO of, is doing great things and was recently acquired by Facebook. And so, still doing great things 20 years after Doom. And we're just really looking forward to his talk, where he's going to just tell us what he's working on and hopefully make it very interactive. So John, the floor is yours. Thanks.
Okay. All right, show of hands. Who's seen me talk at QuakeCon before? Okay, so you know the drill. I'll sit here and talk for a few hours till everyone gets tired. But since this is a little bit smaller venue here, I'm like to experiment with trying to take questions midstream. So I'm going to go in somewhat chronological order. So if you want to talk about something in a particular era, go ahead and get a hand raised, and I'll try to go ahead and answer questions at that point rather than wait until the very end, which may drag out a long time into the future. So usually I'm happiest to just sit down and talk deeply about whatever engineering work I'm doing at this very moment. And I can do that for an almost arbitrary amount of time. But since this was titled 20 years after Doom, we are going to go ahead and take a little bit of a retroactive history walk through the lens of what I'm doing right now in virtual reality. And it's interesting how much things that were done over 20 years ago still have that seed of where I wound up now. So in some ways, some things have come full circle from the way I started out. And also, since this is a university lecture, this was a welcome invitation for me, because I felt guilty these last couple of years since I moved to Highland Park that I haven't engaged more with the university that I'm this close to. I know I introduced the Guild Hall when it was first founded here, and I really haven't had much of anything else to do here. So I'm happy to be here and kind of share some of the experience that I've gotten over all of these years. Now, one of the things interesting is, when I was a teenager, when I was working with computers at the time, I had this strong feeling that I was missing the golden age, that I had been born a few years too late, that all these exciting things that were happening, the Wizardries and Ultimas, these early games that were selling tens of thousands of units on the Apple II, and I was stuck in junior high or high school, just not able to kind of work on these things that I really wanted to at that time. And there was a great book, Stephen Levy's Hackers, Heroes of the Computer Revolution, which I probably read 2 or 3 times when I was a teenager. And I just so thought, I should be here, I should be doing this, I should be in this book, and I was probably a little bitter about it at the time. And that's one of the real things that's come with experience here, is to see that these things where you think there's this opportunity or this golden age, they're just coming along at a regular pace. I mean, all of these things, even if you just look at gaming, I thought, oh, I wanted to be there for those 8-bit, these early 8-bit gaming titles. But there was, after that, there was the Amiga, and then the PC revolution, which I wound up kind of catching on to. And then since then, even in gaming, there's been mobile feature phones, mobile smartphones, Facebook games, web games, free-to-play, Steam, all of these things that have been similar opportunities where, and they're probably happening at an even faster rate. A lot of those happened just in the last 5 years. This isn't where you have to wait another decade for things. So that's one thing that I'd like everyone to take away, that keep your skills sharp, and if you miss an opportunity, you can just wait for the next one. Keeping your eyes open for as things change, there's going to be more and more opportunities. And avoiding chasing the last big thing is probably a really important thing to do, because you can spend arbitrary resources going after something that's already developed. I mean, so many people that want to make games now are just looking at the AAA game titles, these things that now cost $50+ million to develop, huge teams, and there's great work going on in all that, but the exciting things are really happening in the smaller spaces where you can go in, and it may still be a small number of people that can go in and make a difference on something by applying things that maybe worked in a different sphere and now come into kind of a brand new light under new environments. So when I first started id Software, I was working at a small company that, this seems so anachronistic now, it's going to seem, history is another country, where you say that we made subscription software, which sounds like such a bizarre concept today, where people paid money to have a disc mailed to them every month that had random software that they didn't ask for on it. And we made games and other things for that. And it was interesting, but that's where I met my co-founders, and we got together and we started id Software. And that's another thing that I was one of those sort of stereotypical college dropped out of college to go program computers, and look, it worked out well for me, but you need a place there where you can find people of similar interests that you can, to allow you to actually accomplish things that are more significant than you can do alone. For a lot of people, that's college. You can go ahead and find the people that are kindred spirits, people that you can work well with, and a significant advantage of doing that in a university environment is you're not going to get sued when you go off and start your own company with your coworkers. So the first things that we did were very derivative works. I mean, I spent a lot of my time, as you learn your craft, a lot of the best way to do it is by doing derivative things, rebuilding things that you enjoy. My early days were spent making Wizardry and Ultima clones and various arcade game clones. And the start of id Software was making Commander Keen, which was this Super Mario Brothers, not clone so much, but the funny thing was we did literally clone that as our first thing, down to the last pixel. And we tried to start our company by having Nintendo pay us to make PC versions of their games. And that was interesting. We loved the games. We were very happy with the games. We were successful with it. We were going off and building a growing company, having sequels, getting better each time, incrementally improving them. But the real lure for me had been three-dimensional graphics. And I knew this from even the times when I was a teenager. I would draw, the first time I made a rotating cube on my 8-bit Apple II, just to see that flickering across the screen there, and cleaning it up with page flipping and whatever, that sense that great game art is a thing of artistic beauty. It's something that people do, but here was something that was made out of math, and it was something that, with no artistic talent, I could build this thing that looked interesting on the screen. And by that time, there was, we'd all read Neuromancer. VR was a thing even back then. Like when we were starting id Software in the early 90s, Time and Newsweek had VR stories in them. It was in the popular consciousness. You had bad movies like The Lawnmower Man and lots of popular notions about virtual reality. And it seemed like this, this incredible thing. The way it was written about, you would think that, okay, you could don these goggles and gloves and step into this virtual world where it could be anything. And it was easy to sell this as this grand vision because you could talk all of these ways about how this is going to be transformative for society, about how you'll be able to do all of these different things and the human condition will improve. And it was all a load of garbage at that time, the way it was presented, where people were talking about this, this vision. It attracted a certain, and the media was certainly complicit in this, but it would attract a certain type of person that could spin this vision story. And there was hardware that existed. You could point at, a head-mounted goggles over there and this big computer that would be running it. You could point at hardware and talk about a vision, and people thought that they were all connected, that the vision that you're talking about could be realized by that hardware there. And there was a huge gulf between what people talked about and the vision that they had and what you could do at that time. They're talking about how we're going to change the world and empower all of this stuff, but I would look at it and say, well, the pixels are too big, the frame rate's too low, the latency's too long. These are all technical engineering problems. These are not problems for a visionary to solve. These are problems for engineers to solve. And there were calm heads back in the day where they didn't get most of the press, but there were people at some academic institutions and some work going on at NASA that had researchers doing that were aware of the problems. And I have, back from this time over 20 years ago, I've got several books that I bought way back then that I've been paging through again recently, given the recent events. And it's interesting looking at them. Some of them are these things that just make me cringe at just how wrong-headed a lot of the directions that people had were. But then some of them are just eerily prescient, where there was a comment from Henry Fuchs, one of the grand old men of computer graphics, in the early 90s saying, it may be 20 years before this is ready for consumer consumption. And pretty much right on schedule there, here we are. So the The other side of things, though, the hucksters that got attached to this, where it sells a great story, people were able to raise money for different things, and I was involved in that on each of the early 3D titles that we wound up doing. It was licensed for a virtual reality application, Wolfenstein, Doom, and Quake. And you can tell the way this happened. Somebody said, I gotta get into VR. I'm gonna do a VR thing. And they would go and say, well, what can we do? We obviously can't afford this big $1 million Silicon Graphics infinite reality, or reality engine back then, refrigerator-sized piece of hardware. What can we do on a PC? Well, there's this, this hot company id Software that's doing these amazing 3D games. We can use that in virtual reality. And we got approached by these people, and some of them were they were obviously bad ideas. Like, we got paid for Wolfenstein in virtual reality. Now, Wolfenstein was a 3-degree of freedom game. You could move around and you could yaw your head side to side. So somebody built an arcade cabinet, and they had one of the big head-mounted displays that cost many thousands of dollars. You could put that on your head and have Wolfenstein projected on your head, in front of your eyes. And you could turn your head and rotate there. So you could say it's a head-mounted display, it's virtual reality, but there were so many things wrong with that picture, where most of the early virtual reality demos, they were head-controlled demos, where you would not think about what you want from virtual reality is this sense that you are in a different place, that your brain and your sensory systems are fooled into believing that you are actually there. And now that is possible. You get the right hardware, the right equipment, and the software is all set up right, and you can do that to a point where you get this sense of presence, where you can look around, and yes, you're still looking at graphics, you can tell they're computer rendered, they're not photorealistic, but your body can buy into this sense that you are there. None of the early VR demos were like that at all. I mean, I call them head controlled because you could be in one of those and say, well, I want to look over there, and you look your head up, and then the world drags around to follow you there. They usually were not set up so you had the correct perspective. Like, people would take Wolfenstein, which had like an 88-degree field of view or something, and it would be in this random head mount that has a 60-degree field of view. So the perspective's not even correct, even if you were looking at the right area, not rolling your head, doing all of these other things. So it just wasn't even close to right there. But, we took their money for each of these companies to do that. I mean, I could tell early on that this is, these are not going to win. This is just going to lose. But if I feel a little bit bad about, they raised money from somewhere. They took somebody's money and they gave it to us to get our software to make their product that I knew wasn't going to work. But that was, that was the lay of the land back then. I never personally got to experience the very highest end things. I mean, there were systems back then by people that did understand properly referencing the geometry and the projection matrix to exactly what you're doing, and that understood frame rate, and that understood, most of the bad systems were these blurry little LCDs from portable television sets, extremely low resolution, very long switching time, but there were some high-end ones in government labs that had little CRT displays, which maybe you don't want sitting next to your brain for a steady period of time. They were low persistence, low latency, high performance, could be driven by $1 million worth of SGI or Evans and Sutherland image generation equipment. So there probably were some systems back then, but I never got to experience them. The things that I could see were the things that people would show at trade shows or that were portable enough to move around. And we all understood the vision. We understood how we wanted Snow Crash, we wanted cyberspace in the metaverse, this land where we could create whatever we want. But the hardware just wasn't there at the time. And in many ways, there was a severe cultural issue why that generation of VR wasn't going to happen. There was the kind of the huckster culture of, you had people that were long on enthusiasm and short on talent. They could raise some money, they could cobble some systems together, but they didn't have the engineering chops to actually make it better. And it really was premature to do at least a reasonable consumer price point. But there was also that you had the serious people. I mean, there were some hardcore, great computer scientists and engineers that would work on some of these things in government agencies and different DARPA projects and things. But there you had the cultural problem, is they would look down very much on what was going on in gaming, where they would say, well, this is only for serious applications. We can talk about military applications, or how surgeons are going to do telepresence, remote microsurgery, or these things that seemed like these socially gainful things there. And at that time, when we were building, Doom was a huge breakout cultural success, where everybody recognized Doom at the time, but that category of serious engineers, people I respected a lot on a lot of levels. A lot of them would look down their nose significantly at what we were doing in the computer graphics, because if you go back and look at the games as they stood there, 320 by 200 or 240 resolution, these bathroom tile-sized pixels, enormous blocks, no filtering, 256 colors, all of these problems. And you had a set of people that understood image generation, that did like the flight simulators and things, that do 60 hertz, low latency, high quality simulation work. And they would take the point that, well, if it's not anti-aliased, locked 60 frames per second with proper filtering, it's not worth doing. This isn't real computer graphics. No one could stand to look at this aliasing mess. And they would convince themselves that there is no value in doing something on a lower level there. And clearly they were wrong. There was lots of value that came out of this. And as the game industry developed, a lot of these really hard engineering problems, getting the performance of rendering engines, dealing with networking, audio systems, all of these challenges that happen in game development, game developers just said, well, I need to go do this for my next job. It's not a research project. It's not something that, that I'm going to write a dissertation on. It's not something that that is going to feed to the body of knowledge of science and is going to help society. It's just what I need to do. But the problems got knocked down kind of one after another there, until where we are today with the games that we make today. They're magnificent and amazing accomplishments with what we can do with the technology today. And it's interesting that it was done in pursuit of, in many cases, tawdry entertainment. But it's what's driven the development of so many of these things. The many billion-dollar GPU industry was, you don't need GPUs for rendering your spreadsheets there. You need them for playing Quake, GeoQuake and things like that along the way. So it's been exciting to see that, and it's a force that nobody can deny right now, and it's great to see over the last decade or so how a lot of academic work, even on research and simulation and rendering, does wind up being more and more game-focused, because it turns out that's where it's actually going to be applied, not in some DARPA project or something, but hopefully in a game that's going to go out and do some really great things. So the path that we took through the technologies, and I can't kind of go through every single step that went on, what was important and what wasn't, but to take some of the broad strokes. With Wolfenstein 3D, it was interesting in particular because it was almost exactly the same game that I had done previously in a two-dimensional context. These earlier games, before we founded id Software, I was cloning a lot of games. I do something that's like, I was building games that were kind of like the arcade game Gauntlet, where you got guys, it's top down, you run around, you pick up health, you pick up items, you shoot at monsters, you get keys to open doors, and you go down. And I built a game like this in 2D. I made a game called Catacombs. Then I made a sequel, because I was poor and looking for contracts, so sequels are a good thing to do at that point. So I made Catacombs 2 with more levels. And at that point then, I had just begun doing the 3D graphics work, figuring out the texture mapping and what we could do for things like that. So I made a Catacombs 3D as the next game, which was the same game, except it had this first-person perspective. It had this ability to be inside the game world, where you could look at the monsters, instead of being the abstract thing of, you're a little guy here, monster over here, line them up, shoot at the monster, which it can be plenty fun and interesting, but it's an abstract sense that you're clearly controlling these little things. You're controlling these dolls moving around on the screen. Where same code, literally some of the pathing logic was exactly the code that was taken from that. Put it into the first-person perspective, so that all of a sudden you're seeing it in perspective, and you can round the corner and see the monster full size right there. We were seeing reactions that we had never seen from games before. We had people that would fall out of a chair. They'd be walking around, they'd turn around, and literally fall out of a chair. And that's something that games never did that before. You just didn't get that from however intense your 2D shooter was, where you're in the middle of some pitched battle and intently focused, or Robotron or whatever. That can be intense, but it doesn't have that sense of shock. So the notion that a change in perspective can take something that's common or even overdone or past its kind of use-by date there, an old concept, changing the perspective can make that exact same thing then extremely valuable and powerful in a new way. I think that's very pertinent for virtual reality today. I think that there are whole swaths of things that people used to do in gaming, different genres of gaming that haven't stood the test of time, haven't stood up to things in traditional two-dimensional render it on a TV screen, that projected into virtual reality where you're in there with them, they're going to add a whole new lease on life. And I think that all of the different tropes and genres that we have in gaming, we'll get another kind of shake through the sieve of virtual reality to see what winds up working out much, much better there than it did in the previous cases. So I'm excited to see people go in and take their favorite genre from some previous old game console or something and see what's this going to look like in virtual reality. As well as the obvious things about, okay, we want to have our latest and greatest AAA title running in virtual reality because it's just going to be awesome on so many levels. But there's going to be surprises and things that the games today are so finely tuned for how people react to things on the screen. And they're wonders of design in so many ways on all the subtle things that happen in the way we present information, the overlays that get put up, the way characters interact and respond to interactions there. And all of those need at least a reevaluation in virtual reality. Because in many ways, while there's obvious parallels between film and traditional gaming now, virtual reality is more like street performance, where you can't just grab a hold of the camera and push it the way you want to go. You can't really do cutscenes in virtual reality where you yank the view away and start showing people. You have to attract their attention and hold it. And so there's interesting things that are going to happen with game design on that level. So after Wolfenstein, we had the big, obvious breakout success of Doom. We've been following this great arc that we've done, Commander Keen and the sequel to that, a commercial game, Wolfenstein and Doom, and there's this lovely trajectory where each thing we did was a couple times more successful than the previous thing, but then Doom was a breakout. It was an order of magnitude bigger than what we had done before. And from a business standpoint, there was a lot of interesting things about how, as our small little company, we got, in some ways, really taken advantage of as a business. We didn't know how to negotiate royalty contracts and for commercial publishers and things like that, but it was still, unquestionably, this monumentally large success. Some of the things that drove the technical directions there were, it was surprising for us with Wolfenstein, when we saw people poking at the game, when we saw them going in and changing things around, modifying it in different ways. It was great, and I recognized it immediately, because that was what I was doing on my old 8-bit game. You get the sector editor out, give yourself 255 gold pieces here, and I instantly empathized with the people doing that, but we hadn't planned for it in any way. And it was surprising that people were able to reverse engineer some of the tools that we had done for that, because back in those days of floppy disks, like the levels were compressed twice in two bastardized versions of Huffman and LZSS that I independently implemented badly. Interesting coming across some of those things, but people decrypted all of that and started modifying it, and it was obviously a wonderful thing. So with Doom, I had taken the standpoint that, okay, people want to create, it's a good thing here. Let's actively go out of my way and build a technical platform that will let people create lots and lots of things, not have to go through these arcane and abstract ways of going in and poking at something there, but setting it up, expecting it to be built so that people go and modify different things. And that gave us all the characters, the levels. We released the code for building the different things there, which is the first of a lot of code releases that we did. And that was one of the huge aspects for it. So there were a number of keys to Doom's success, where the graphics were obviously the thing that people noticed. It had the lighting, the arbitrary geometry, the more geometric complexity than we had. It wasn't just blocks, it was clearly something that could be designed. And there were some things that just looked really good, better than anything that had in a game before. But there was the modability of it, which kept, added tons of legs to the game. And then there was the multiplayer aspect to it, where we had the ability to let up to 4 people connect together, or 2 people over a modem. And this was, we were actively going towards this sense of, well, we want this virtual world. We want to be able to go in here. It was still clearly games at this point. You set up a game, everybody joined, you played the game, and you left. But there was still that magic of being able to be in the same game world with other people. And people pushed that further than it was intended to, where there were like a wide area network stuff over phone lines that just barely worked, and some people could get the IPX routing over different networks. And you had some people that were the pioneers there that could say, man, I just played a game of Doom with someone across the country. Isn't that awesome? And there was that sense of, you could tell that this was going in that direction, but being the pioneer there in those early days, when you had to configure all these crazy drivers and hack different things on the startup, run a different initialization program to get to it, but it was an exciting time for a lot of people that way. And in many ways, Doom was probably an optimal product, and I don't think I can say that for for just about anything else that I've done. Now, shortly after, certainly with 10 or 15 years of hindsight, I could go back and anything that was done in Doom, I know how to do better. I know how to make it better for consumers, run faster, use less resources. Everything that was done in there can be improved on. But there's always this knee of the curve of when you're engineering something, there's the effort that you put into it and the value that you get out of it. And there's going to be a sweet spot where you can continue improving something, gold plating it forever. You can polish something endlessly. You can always find something to improve. But beyond a certain point, it just really doesn't matter. And I look back, and I had the good fortune for me many years later when we were doing some mobile work, and I rewrote a software rasterizer. You know, I hadn't written a software rasterizer in 15 years. And I went back and I knocked it out in a couple days, and it was better than what you had on Doom. It had more flexibility, more feature, probably higher performance on that. And say, well, I could have done this back then if I knew a little bit more, if I was a little bit smarter about it, but it really wouldn't have mattered. And there's some important aspects to that where it's easy as an engineer sometimes to get wrapped up in specific techniques, to find the way that you do things, and to realize deeply that it doesn't matter that much, that there are in almost all cases many ways of approaching a problem. And even in the specific cases of, like back to Wolfenstein, where I had written the Catacombs 3D renderer I was trying to render it as like polygons, and I just did not have enough time to get that working well. Wolfenstein switched to this raycasting approach, which technically should have been slower, but because it was simpler, I could optimize it better, and it worked out to be a more robust kind of shipping solution. And with Doom, I started off one direction, it wasn't going really fast enough. I went and I did a bunch of console ports, and I had to make Wolfenstein run on the Super Nintendo, and that was when I learned about BSP trees and some of these algorithmic directions. And I applied it to Doom, and it was a great success for us. But one of my peers, Ken Silverman, made the build engine for Duke Nukem, Duke Nukem 3D and all that. He did a completely different thing, and it worked just fine for him. So there's lots of different directions, and it's important to get to the necessary level of quality. But it's easy to overdo it. It's easy to not know when to say it's done, it's ready to ship, it's time to get this out the door. And having that knowledge at a systems level is one of the things that's particularly, it gets harder the bigger the company is. In the early days when you've got 6 or 8 people doing something, you can all reach kind of consensus and set your lobby for your particular viewpoint and fight your battles there. But it gets really hard when you've got 50 or 100 people working on a project. How it's easy to lose sight of the value equation there, where everything that you're doing as an engineer should be in service to the consumer, who's going to wind up using your product at the end of it. And it is all too easy to get wrapped up in some little thing like I could be doing static code analysis and say, I'm being virtuous, cleaning the code base, removing these potential faults for it. But that's a couple steps away from the value of what the consumer is going to get. Yes, nobody likes a buggy game that crashes or has security holes or different problems like that. But I know I was guilty of that at some points later on about when we've got so many people working on so many different things, I could be working on something in my little hole of the code and not paying so much attention to, well, we need to care about the end user value. So Doom was probably just about perfect there. It delivered huge value that nobody had ever seen before. Nobody had seen graphics like that, played the 4-player action game like that, modified games like that. It cut a bunch of new ground. So we were riding really high off of the success of that. And when you're early 20s and you have a success like that, you go out and buy Ferraris. And it was a good thing to have back then. I kind of figure I was immunized against a later midlife crisis by going and buying a bunch of Ferraris in my 20s. So in my 40s, I don't really feel the need to go out and get a fast sports car or anything. They turned into science projects, and I've got great car stories to tell about 1,000 horsepower Testarossas and all. But coming off of that, there was this sense of, okay, we are so awesome. We've gone through this, this level of scaling from the side scrollers to Wolfenstein to Doom. How do we top this? And I set out with Quake to say, well, what's everything else that we can do here? We can remove all of the restrictions of Doom on geometry. We can be arbitrary geometric modeling. We can be 6 degrees of freedom looking around so that you can be looking up and down, have your head kicked sideways. You can have accurate lighting that's ray traced or radiosity-based lighting there. We could have play over the internet. We could play over TCP/IP and UDP actually instead of IPX and the local serial networks. We could have persistent servers so that the server's there whether the players are or not, that the server could be a place. And I had this whole spiel about this, about how we could build these servers and connect them together. And that vision was what allowed me to recruit Michael Abrash away from Microsoft, from a good position there to come down and work on games with me. Which he's joked on later years that he doesn't regret it at all, but it was the worst financial decision of his life to walk away from all of those Microsoft options to come make games and its software. But it was a compelling vision where you could say, these servers are going to be there whether people are or not. It's going to be this virtual realistic. You're going to be able to walk around through these game worlds, maybe run into your friends. And there was a time there early on in Quake especially where when people were new to this, when it wasn't all about racking up the frags and getting the high score there, where you would have servers that was a neighborhood server that people would show up on, and it was just a place, and people would be there and type to each other and kind of go around and just marvel at the situation that they were in. So it was a lot to bite off, and in fact, it was really too much to bite off, and it was the project where setting out to do all of these things, and in a certain time, definitely did not make it in the time frame that we wanted to, and we wound up having to cut back some parts of the vision that we wanted to get there. And that was really an important lesson for me where I first came really face to face with absolute limits of what I could accomplish. There was, when you're young and optimistic and talented, you go off thinking, I can do anything. And I still am arrogant enough to think maybe I can do anything, but I know I can't do everything, and I can't do lots of anythings at one time. And there was, real tension through all of that, where it's like, okay, I'm working absolutely as hard as I possibly can. Just 7 days a week, 13 hours a day, and it's just not going to get done. It's not going to get done when we thought it was. We're going to tear things off. It's still not going to get done. Eventually, it did get done, and it did have the major things that we wanted there. It had the extreme modability, the dedicated servers, and the 6-degree freedom graphics. But if I looked back at that project, we should have been one step less ambitious. I really should have just kept the extreme modability with the scripting, the internet dedicated server play, and done it with a Doom level engine. Because we wouldn't have been pushing it to the bleeding edge of people that had the Pentium computers that could run the game well there. We could have done better and probably been a little bit less afraid at the whole process there. The scripting language side of things, Quake C, was an interesting aspect of this where with Doom we had this ability to make all this static world. Amazing things, people did wonderful stuff with it, but you couldn't really change the game too much. And just like we were surprised when we saw people going in and binary editing Wolfenstein to do things, you did get the extreme people that started basically disassembling the Doom executable and finding out how to binary modify it to do certain new game things, the dehacked stuff. So that was the obvious thing that I needed to fix in the next generation, that I needed to have some way for people to write real new games, to be able to express themselves as a programmer, not just as an artist or level designer, in a new way with the games. So, like has happened with many projects, you wind up saying, well, I need a scripting language, and it's a different world back then again. So of course I say, well, I'll just go write one. I had written some compiler stuff before. I had retargeted a compiler while I was doing Jaguar Doom, and I had experience with that, but it was totally ad hoc, seat of the pants stuff. It's this quasi-object-oriented approach where you've got the entities in the world and you can assign things on it, implemented in an imperative manner, but it worked, it was great. There were lots of people that got their first start programming in Quake C. But as the years have passed, I've wondered to myself if maybe I could have done better for the world if I had used Scheme or some other small language and gotten people learning. If they're going to learn a first programming language, don't learn it in some ugly hybrid of a thing that was really not well thought through. And of course, we see that all the way to today, where JavaScript was implemented that way, where somebody just said, I can go write a programming language, I'll get it in, we'll script our web pages, it'll be fine. And the consequences of that have been enormous. You never know when some little decision that you make on implementation, they may wind up having world-changing implications later. So that was that was an interesting way of doing things. As we went to Quake 2, we made the decision that this was going to be a conservative project, that we weren't going to reinvent everything because there were battle scars at that point from going through the Quake development. And we picked a reasonably conservative target. I added colored lighting to it. I switched the scripting back from Quake C, which was clearly showing its limits, to a DLL interface. And it was, at that time, our most successful project, our smoothest running one. And there was a clear lesson there about how if you want to, you can pick a conservative product, innovate in a couple small ways, and maybe get things done roughly when you think they're going to. It's when you try to reinvent 3 things at once that you really wind up running into problems. The switch back to native code for the implementation of the scripting language was something that I struggled with quite a bit, because at that time I was aware enough of security issues to think that we just don't want people downloading native binary blobs and running them. But it was, we were seeing all these Netscape plugins and eventually ActiveX stuff. It struck me as so curious that this was happening and it wasn't disastrous. And it's still surprising to me that more game type things haven't been security disasters. That it's the topical point, the topic of the month with Heartbleed and everything, how it's so easy for anything that's network accessible to be exploited in various ways, especially if it's written in a memory unsafe language. And you expect some level of oversight in your SSL or whatever, but games are driven by get this done at this point as quickly as possible. If people can talk to each other, who cares? And in later years, one time when I wasn't doing the network code, I spent an afternoon doing kind of white box penetration testing and said, well, let's go ahead and just step through all of this. And sure enough, within a couple hours, I found a buffer overflow in some of our code. Now, it was code that was, in theory, debugging code. In theory, it shouldn't have shipped, but that's led to many, many problems over the years. And the game developers security is not their priority. And I am surprised that there hasn't been some global catastrophe of some, one of these games, especially the free-to-play games now that have obvious network connections and are being played by millions and millions of people. It's kind of terrifying if I sit and think about it too much. And that was one of the reasons why with Quake 3, I made the change back to, I think I took the best of both worlds with Quake 3 Arena, where we wanted the flexible scripting language, but I wanted something that wasn't an insane binary blob to download. So I implemented plain old ANSI, and it could be either interpreted as essentially a bytecode, or it could be compiled and run just-in-time compiled on some platforms, or you could, if you wanted to and understood the risks, download a binary blob. So that was, in many ways, Quake Arena, Quake 3 was the kind of culmination of one of the major technology arcs. By this point, I had done these engines 3 times. We had been through it enough. We understood a lot of these issues. But the couple things that we were trying to innovate on there, it was a negotiation amongst the amongst id Software for what we were going to be doing with our products. I really wanted to do Quake Arena because I wanted to do a GPU-focused game, and I wanted to do a multiplayer-focused game, but that was not a universal opinion in the company, and there's good reasons for it, where on the networking side of things, we had plenty of people playing Quake online, but plenty does not mean that the million-plus people that you want to buy a game of that caliber at that time. There was the real question of okay, most people still have modems, and a lot of people were at the fairly bad modems. And in fact, as modems evolved, they got worse for gaming when they added all these layers of compression and error correction there. So when we were making Quake, we were thinking, God, it's going to be so great when people have bandwidth and connectivity such that we can build a multiplayer-focused game, that we can do something that's built around this. But it clearly wasn't the case at the time of Quake. We were all spoiled with our T1 at the office, and in the community you had most of the people on modems calling the other people LPDs for low ping bastard that's on a T1 at their university somewhere, getting all good kills on everyone. But it was changing, and that's another one of those things that you get with a decade or two of kind of historic retrospective perspective on things, is that there's this notion that people in general are bad at estimating things, where we overestimate change in the near term and underestimate in the long term, presumably because we tend to think in a linear fashion, but a lot of things are exponential. And I can remember back then thinking, damn, people are never going to get this bandwidth. And if only people would get ISDN, if they would get this 56 kilobit, but reasonably low latency, predictable path, better than the modems. And that wound up being pretty much completely bypassed. And now we've got people saying it's not broadband if you've only got 1.5 megabits to your home for stuff. And that's, we are 15 years later after these early games, but that's an amazing amount of progress. And then on the GPU side, there was the case where we took some pride in the early years about our games were a lot of impetus for people to upgrade their computer systems. People would go out and they'd buy a 386 to play Doom, they'd buy a 486, or they'd buy a Pentium to play Quake, and then they would buy a graphics accelerator to be able to play GL Quake. And this was one of the things that I missed a lot, but at that time, after we had shipped Quake, while kind of the rest of the company was building this derivative product with Quake 2 in some ways, I was doing these experiments, and this was, we don't see this in the gaming industry today, and it's a damn shame, but I was able to take our media and make these experimental products that we just released for free. I made Quake World, where I was experimenting with lower latency prediction for better network play, because the original Quake, it played good on a network, it did not play well on a modem, it just wasn't a good experience. So I was able to do this research release that included this stuff, and there's a whole separate community, and to this day, there are still people that play Quake World and people that play Quake, and they're different communities, and it's interesting after all that time. But then the other one that had really far-reaching repercussions was the desire to make a hardware-accelerated version of Quake. And the first one that we did was for a company called Rendition, and they had a nice low-level API. It was a cool graphics card that you could basically write assembly language for it. And Michael Abrash did a whole bunch of really low-level stuff on that to make Quake run well on it. But the next thing that happened there was we had 3DFX, which was a company with the Voodoo graphics cards, which was several times more powerful than really all of the other cards there. It was really a fantastic piece of technology from a gaming standpoint. But they had their own proprietary API. I was busy with different stuff. I'm like, I don't want to. We had, this is again a little bit hard to see from today, but there were at one point 13 different chipsets that I was testing the graphics games on, and this was clearly going to be a nightmare writing each one of these separate application programming interfaces. So we were, at that time, as we were migrating from Quake to Quake 2, we were migrating from developing on Next workstations, which was an interesting aspect of the things that we were using Unix workstations to develop PC DOS games, but that was kind of folding up as Next was looking like they were preparing to go out of business before they got saved at the end by Apple. But I was evaluating whether we were going to go to Silicon Graphics workstations, Sun workstations, or NT workstations. And what I had done at that point to evaluate it was I had taken some of our basic geometry and I wrote an implementation that let me run it on the OpenGL interface, which was SGI's graphics programming interface. And it was interesting that I was able to take that and run it on a couple different platforms. And again, it sounds pretty plain and blasé today. You think that, okay, cross-platform portability, different things. But it was exciting at that time when I had this stack of all of these different respective graphics cards that had their own private interfaces to everything, and most of them were messed up horribly in some way or another, to have this interface that I programmed to, and it pretty much just did what I wanted when I asked it to, which was exciting, and then to be able to run it on a completely different platform after recompile was, that was very promising. It's kind of, when you're in tech and you just get, when something just works for you, it's very pleasantly exciting, something like that. And part of the reason for that was it was already version 2. OpenGL was SGI's reinvention of IrisGL from their proprietary hardware, and it was really pretty good. I was surprised at how often it worked for what I wanted. The other standards-based contender at the time was Microsoft knew that everybody in the PC world knew graphics accelerators were going to be a big deal. So we need to have some interface for them. Everybody saw the 13 different chipset vendors, and we needed some way to program to it. And it was interesting because Microsoft actually supported OpenGL on Windows NT. That was their workstation-grade implementation for graphics. But they felt they needed to do a game-specific API. And that happens a lot because there was a certain hubris in the game development community that was in some ways a backlash against those simulation snobs that would look down their nose at the tawdry titles that we were doing. And we were all like, we need this lowest level access to this. We can't be using some API that people use on workstations. That can't be any good. So there was this disbelief that could be possible. So I was really surprised when it actually worked out really well. And to be fair, to be a good engineer and do a side-by-side comparison, I took the same code and I reported it to Microsoft's Direct3D, and it was terrible. I mean, it was incredibly bad how it came out. And you could see how it happened because they had hired people that were software developers and understood high-performance software engines, and they built an interface to hardware that was what software people thought they wanted based on their experience with software. And it just wasn't what the hardware wanted. And anytime you've got an impedance mismatch like that, where somebody's trying to push through something that's not really fitting, it's the square peg in the round hole, it was bad. And there was a lot of drama at the time there about how OpenGL versus D3D, Carmack versus Microsoft, and it's worth mentioning about how Microsoft has a way of doing things where there is a strategy, and it's probably even conscious and explicit to them. You get something out, but then you make it better. And they did. Direct3D got a lot better to the point where, I would say that D3D9 was better in a lot of ways than OpenGL, contemporary OpenGL at the time. And you can make arguments depending on the time of the year that you're in and the season of extensions versus DX specs today. But they're at least comparable and in some ways arguably better. But at the time, it was terrible. And I was using, I had this crusade to push OpenGL and get vendors to. I had a big stick at that time where I said, I'm not doing a D3D version of Quake. If you want Quake, you're going to have an OpenGL implementation. And it worked. I got a lot of vendors supporting OpenGL, sometimes disgruntled. I am not exactly wanting to support it, but doing it anyways. And it was good because in a funny way, out of all of these kind of accomplishments and things that I've done with the games that millions of people have played, it could be argued that GL Quake, giving OpenGL the support that it needed to stay relevant for a period and not to be squashed by Microsoft, meant that OpenGL was still around and relevant when mobile came around, and mobile adopted OpenGL ES. And in a funny, peculiar kind of way, OpenGL sort of won. At the end of all of this, we've got 1 billion devices running OpenGL ES in mobile, and yes, 90% of the PC games are D3D based, but it took over on the Macintosh. That was also one of the Quake 3 wins there was re-engaging with Apple and the beginning of kind of a relationship there, and that was my deal with Steve Jobs, that Apple supports OpenGL, and I personally port Quake 3 to Mac OS 9 at that point, which was an operating system that I thought was terrible and I didn't like, but I will personally do it, and it will be damn good if you take my advice. Heed my advice. This is the right thing to do. You want to be able to target workstation applications. You don't want to use your homegrown rig, quick draw 3D stuff there, and that was. And we won on there, and that was a good thing. It was the start of, there are Steve Jobs stories to tell over the coming decade after that of the different things going on, but getting Apple to adopt OpenGL, having it still be relevant so that it could be used on mobile has been one of the more impactful things that's been done. It comes out of some of those engineering decisions made way back then. But still at the Quake 3 timeframe, GPUs, they were there, they were powerful, but anytime you wind up looking at the numbers of stuff and you say there's XX millions of PCs and only X millions of them have GPUs, do you want to be limiting your target market like that? And those are always valid business decisions about how much of your market do you want to address, bleeding edge versus all-encompassing. And there's conflicting data on what the answers to those questions are, because from id Software's standpoint, when we have these cases of supporting a trailing edge platform, whether it's CGA graphics in Commander Keen, or looking at EGA and Wolfenstein, or without GPUs and different things, or 486, each of these times in our market, what became the hardcore gaming market, it made sense to be aggressive, to kind of throw away the low end, to do something better there. But in recent years, we've got the kind of counteracting tendencies of people that have gone really wide, people that have done some of the web games or Facebook games that are getting incredible numbers of users. I mean, you get things with 100 million plus people using some things, and that does not come by catering to the bleeding edge. So there are lessons that have probably changed over time, and honestly, that's one of the significant arguments inside virtual reality now about how high-end hardcore do you need to be, where we have an existence proof with the Valve Room of a system that runs a certain set of content at a level that definitely delivers presence. But it's a system that we can't sell. It's a system that requires somebody to dedicate an entire room, cover it with fiducial markers over all of the walls, have this crazy high-end PC with this custom head-mounted display, the stuff that it would cost $10,000 or something for all that, and a room in your house. You can't ship that to a consumer. So how many steps back can we take from that? Can we deliver something that people can run on a laptop? Can we deliver something that a mobile device? And there are active arguments inside Oculus about what level is necessary, because there are aspects to the perception and presence and a sense of being there that influence more important things than they did in 2D, where the sense of simulator sickness, where we have our proof of concept of nobody gets sick in this room, but we can't ship that room. What can we give up from that to step back down? Can we trade off something in frame rate, something in latency? We have schemes and strategies for things that we think can help let us do it on lower-end platforms, but those are important things that we're still really figuring out. So Quake Arena was a little bit of a stretch there, where we were looking for people that cared about multiplayer, had a decent enough network connection, had a graphics accelerator, but it came out, it's probably still what I look back as my favorite title. It was a pure play, it was simple, it was elegant, I was proud of the title there. But part of the internal negotiations that happened with that are, a large chunk of the company didn't care about multiplayer games, wanted to go back to building single-player, kind of more artistic-focused games, and that was the deal that had been struck. After, we're going to do John's game with Quake Arena, and then we're going to go back and we're going to do a single-player-focused game that became Doom 3. But I made one attempt. There was a road not taken that happened after we shipped Quake 3, where I got the whole company together, and I made a pitch saying that we've done this now 3 times. We've made 3 generations of games. I think I've got a pretty good idea about how to make this more flexible, how to make it extensible, and put it on the web, and be the prototypical larval phase of this cyberspace that that we've wanted, that we've been talking about for a decade at this point. And I did some hand waving and talking about how maybe it wouldn't be quite as good as if if we're dedicating something that's absolutely going to be a game focus like here. We can do better things. I can do better graphics. But I can do something. I can do something of value here that I think will be past this threshold where it can be useful, where it's not just this, this pointless exercise there, where people could build, use it as a platform. And and it didn't go over well. I mean, their response from people was, "John, we make games. This is what we do. This is what id Software is." And and I knew I wasn't going to pitch a fit about this because I had already made the bargain before Quake 3 that it was going to be Quake 3 and then we were going to do a single player game. So I figured that the deal's been struck, so we set out back into single player land with kind of vestigial multiplayer on that. And that was really the start when the developments really got out of hand in terms of how long it took us to make the games, how much content was required. We were taking 4 years for that title, 6 years for the title after that. And there were some significant things lost in that path, where gaming had matured to the point where it was an industry. It was a serious industry, making billions of dollars. It had been great to be see some of the DNA of the earlier things. It's great to see going through there where Quake was the underpinnings for Half-Life and all the Source Engine games. Quake 3 was our most widely licensed engine that still lives in tiny little bits and crumbs of code in Call of Duty today, which is amazing to think of. But it was not quite the Wild West anymore, where throwing everything out and writing it all from scratch again was probably not the very wisest things that that could be done at that time, because rewriting everything just got bigger and bigger, and it took more and more years to go through and build each project. So there was, I do look back at it as kind of a little bit of a turning point where we became dedicated to building significant projects as part of this larger and growing industry. We were looking at the consoles were becoming more important to us instead of these after-the-fact things. We were building some of the, making some of the fundamental decisions around what we would do for that. But we, again, ripped up all sorts of stuff at this point. We rewrote everything in C++ at this point. I was kind of a latecomer to that, where I could be reasonably considered expert in C at that time. I was writing compilers. I had done all these generations of code. But it was kind of funny the way it all worked out, where I had done Objective-C on the next workstation, so I knew object-oriented programming, and I was very good at C. And I figured, well, C++ is just kind of Objective-C and C smashed together in a different way. And looking back on it, nothing catastrophic came out of this, but I can't how I just kind of backed into a new programming language, where we had a few people at the company that were programming in C++, they were writing C++, and I just kind of started writing it, along the way, looking at what they were doing. And years later, wow, if I had been able to read effective C++ and a few other things and just actually studied a little bit before just kind of sliding into a new programming language, things would have worked out probably a lot better. But in the end, it was not a bad code base. We did good things with it. We set new high-level marks in visual quality. A lot of the things that are standard, kind of even to this day, with the way normal mapping and baking high poly models down onto low poly models, and unifying lighting and shadowing. There was a lot of things that I was proud in there, but it was just polishing the graphics. The networking took a step back in that because that wasn't our focus, and that was the deal. We were doing a single-player game, and multiplayer was not going to kind of keep the development. But it came out, it was our most successful product at the time. For a while, it was the fastest-selling PC title, and it was, by all measures, reasonable measures, a very big success. But it didn't have some of those things that felt like the soul of the earlier projects in them. And then following that up with Rage at a 6-year development cycle, we spent an entire console generation. We were doing cross-platform development where it was cool technology we could deploy on the PC, the 360, and the PS3. And it was very high-quality code. It was all tightly analyzed. We did great work through all of that. But it just took too damn long to create. By the time we were done with it, many of the design decisions and things that we would be looking at on there were no longer what they should be. And there was a real acknowledgement from me consciously that in the early days we took this pride about when's the game going to ship, when it's done. We were our little independent company. We weren't relying on publishers. They couldn't push us around and tell us what to do. We're not going to ship something out before it's ready. And that's still absolutely valid. But to just say, it'll be done when it's done, I've recanted from that position where timeliness really does matter. You can't just always trade away and say, well, it's going to be better if I work on it longer. At some point, you may have to realize that either you made a bad initial decision and you picked a set of targets that don't have something that you can rescope to and actually ship in a timely fashion, or you need to find out what you can refocus on and say what was really, really important, because I dearly wish we had shipped 2 separate games instead of 1 game in 6 years. I wish that we could have taken earlier stuff and iterated on it, because 6 years, that's longer than people stay in school to do 1 title. You learn so much during that period. If you haven't been able to reapply that to a design early on, it's a big failure. So technically, something I'm very, very proud of. I'm kind of saddened that it's likely that code base will never be released open source. The open source code stuff over the years has been something that I've taken a lot of pride in, where the early code that we released was under restricted licenses. There was always the internal debate that we don't want to help our competitors. That's just, if you're a business, there's something to be said about. You don't want to just, hand your competitor the knife that they're going to stab you in the back with. So it's a tough argument to say we should give anything away. But the benefit that we got from the community, the mods, all this stuff out there, it really was worth it. And everybody in hindsight agreed that it was, but they were hard arguments to make early on. And being able to do that for each generation, it gives me no small amount of pride to understand that every 32-bit processor in the world has run Doom. It's like the bring up. People have told me that when they bring up a new processor at ARM or someplace, one of the first things, if not the first thing that gets run, is somebody runs Doom. There are all the stories, people run Doom on a toaster, people run and that's great. And there's been a lot of value to having that out there. It was fabulous that I was able to derive some real value from it when I went back and ported Doom to iOS. Instead of starting with my old code from 15 years ago at that point, I went and took one of the maintained versions that people had done, put 5 years of extra coding in, cleaning up and straightening out, and fixing bugs that I had left in the code there, and I was able to start with the open source version. And that was great. That was the way you wanted that to work. And it's sad whenever I've got a situation now when that's not possible. I mean, now at Oculus there was a painful thing just last week where I'm looking, I need a KD tree-based ray tracer. I wrote a really damn good one at id, and I just can't use it now. That's not available to me, so I'm going to have to go and likely find some other implementation rather than re-implementing it. But that ability to reuse the code has been really great, and there's code that it's interesting. You can go back and look at the crazy, silly stuff I was doing in Doom 20 years ago. I mean, I did not know how to properly clip lines, so I was doing walls as polar coordinates. And polar coordinates are easy to clip. You just saturate a number rather than having to divide and figure out these fractions and stuff that I just didn't understand well enough at that time. And there's lots of stuff in there that everybody nowadays that looks at one of these plays one of the OpenGL versions. But you can go back and look at how I was doing the software rendering. And yeah, the assembly language is still pretty good, but the higher level structures, lots of linear searches through lists and different things that when people made crazy levels that really tore down the performance until somebody added hash tables. And by the time we got up to Quake 3, I thought that this is pretty good code. I'm happy to have people look at what I wrote here. I can always go back and say I write a lot of things better. I'd be const correct through everything. I would do additional static analysis on all of it, but it's pretty good. And then the Doom 3 code base had a bunch more people working on it. It was our first foray into the object orientation, but it's also pretty good. But there's a lot to be proud of in the Intech 5 code base. I am still very thankful that ZeniMax supported me doing code releases for the Wolfenstein enemy territory, allowing me to do the GPO mobile work and some of the other things there. But I wouldn't hold my breath for an Intech 5 code release coming at any time in the future. But so during these long marathon developments of Doom 3 and then Rage, I had these opportunities to go and spend a little bit of time to kind of keep myself sane working on a small project. We didn't have any more of these small experimental things that I could do. I always wanted to take Doom 3 and do like a random level creator and do something more multiplayer focused, and we just never did those things anymore. There was QA process and publishers involved, and it just didn't happen that way. So what I wound up doing were some mobile projects. And this was, it happens it's not a grand strategic thought. It was, my wife got me a new mobile phone at some point, and I looked at it, there's some games on there, man, these games are terrible. The specs of the phone, it's like, this phone is pretty powerful. It's got 16-bit color graphics and megs of memory and all this. And I'm like, well, I'll poke around a little bit and see what I can do. And that was, again, the benefit of an open platform there. That particular phone was a J2ME or a Java phone. So it was not a closed platform. It wasn't like getting your Nintendo DS and saying, how do I become a DS developer? You apply to Nintendo. For the Java phones, you just get a cable, you plug it in, and you download the SDK. And it's terrible software development stuff at that point, but you could still do it. It was that sense. It felt almost like one of the old computers where you just download all this, and set something up, and hey, I've got a little picture of an image showing up on the phone. And that was exciting. We were stuck in these long cycles with no end in sight for the mainstream projects. The idea that, maybe we could just throw something together, kind of quickly on this. It'd be like the good old days. And I did go and say, there was this feeling out process saying, look, this was a new situation for a long time. We had been prisoners of our own success at id, where we made FPSs. We invented the FPS. We make FPSs. Every product was an FPS. But to step back and say, well, this is something new, and it's actually not fast enough at that point to do an FPS, so I get to go do a different kind of game. And to step back and reevaluate all of that, and we wound up with doing Doom RPG, which was, yes, it leveraged our intellectual property, it leveraged my being a 3D programmer, but it was this sort of turn-based-ish RPG thing, and it was great. It was a success. It was not a world beater where we didn't sell millions of units, but we made money on it. We followed up on it with Orcs and Elves and Wolfenstein RPG, and these were. So we were there in the mobile space, and then the iPhone came out, and that was one of the, we had a big argument about that where the iPhone, I think this is going to be big now. I think this is going to be something we can do awesome stuff on it, not these little games that we're making. But we were, again, sort of a prisoner to our own success, where we had this stable, successful mobile line that was, that was generating revenue. We had kind of the development team sort of booked for all of that. So we kind of missed the first great window of opportunity there. And it was only when when Cass actually got to it and was doing some iPhone work, and we just said, more or less one night, let's make Wolfenstein run on here. And that was, again, me just saying, well, I can steal a little bit of time. It's not like we're in continuous crunch on these multi-year projects. Let's just go do Wolfenstein. And it was great, it worked, it was fun, and followed that up with some other stuff. So it was, but there was still that sense that all I got to do was spend these little bits of time on the project. So we were there with mobile, and that's kind of hurts in retrospect, where mobile became incredibly huge there, and we were doing mobile work, we had everything, we could have kind of plowed through and done that, but we weren't. We were focused on the big projects. And similarly, we had there was the idea that we were going to do free-to-play with Quake Live, where we're going to take the old project that I loved and see if we could find a way to do it without requiring people to pay. We were looking at in-game advertising, which turned out to be a fail on the PC platform, but still the idea there that obviously free-to-play is huge now, and it was another kind of ball that got dropped there, where we were kind of there. It felt like something worth doing, but we were focused on other things. Then, after we finished Rage and we shipped it, I treated myself. I said, okay, 6-year development process, I'm going to do something kind of fun. I'm going to look back at the head-mounted displays in virtual reality. It's been 15, 20 years since I've looked at this. Surely they've sorted out all the issues by now. We're looking at computers that are close on 1 million times more powerful than we had there. Surely, all the awesome stuff that I wanted to do back then, somebody must have come along and just done it by now, because you don't get that many orders of magnitude of power improvement and not have stuff just almost spontaneously happen. So it was shocking to me when I went through, bought some head-mounted displays, and they were still terrible. It was really startling. And I've had this in some cases where you misunderstand kind of the nature of the problem, where, like when I was building rocket guidance systems for Armadillo Aerospace and I got into it, I just naively thought, well, surely there's just a sensor that tells you where it is and which direction you're pointing, like a super GPS or something. And no, that's totally not the case either for aeronautics or for head-mounted displays on there. It's a bigger problem than it sounds at first glance. But still, I was surprised at how bad the head-mounted displays were. We had a generation of consumerized versions that were pitched as kind of portable movie theaters. You had the watch TV or something in these little sunglasses, but they weren't virtual reality glasses. They don't put you into this virtual world and let you explore and sense it. It's a little display, postage stamp size display, stuck close to your eye. But when I was looking around at this, I'm looking at this and saying, okay, nobody's done it yet, but it sure looks like all the pieces are actually here. I mean, obviously we have computers 1 million times faster. The computer, your iPhone is more powerful than the infinite realities that ran the refrigerator-sized computers that ran those old demos there. So we've got that well and truly handled. So what's the state of position tracking and head-mounted displays? And so on the tracking side of things, it used to be in the old days, people would use ultrasonic tracking and a lot of these things that required a lot of processing, and they had a lot of lag to them. But we have all these micro machine sensors nowadays, the silicon machined rate gyros and accelerometers. These are cheap. They're in everything. They're in the phones and all the little tiny sensors. And sure enough, there are some sensors that work pretty well for doing that. But most of the code that was written for them was just terrible. It was code that was, in some cases, I'm still not even sure how some of that code was that bad, where it's an amazing thing that you see in so many aspects of the world today where computers operate in the realm of nanoseconds. But so many things that you ask machines to do can take seconds sometimes. You know, and so you think, how can you squander billions of cycles? I mean, how does this happen? But every time you like press your TV remote control and you say, it's like, why does it take 2 seconds to change the channel? You know, how can this take 1/10 of a second for this sensor to tell me what the new position is here? And there's sad, unfortunate reasons why things wind up like that, but they don't have to be like that. They happen like that largely out of people thinking it's not a problem. And maybe in one case it's not a problem, but when you pile one of, yeah. Oh, okay, I'm out of time. Okay, quickly. So starting with the head-mounted display stuff, working on that, it became clear to me early on that we could do what we wanted with virtual reality at this point. We had the displays that you could get on cell phones were, heading up towards full HD there. Sony was releasing an OLED movie viewer there. The sensors were good enough to my view on what I could have there, and the processing was obviously there. So I was tinkering with this stuff, and I had made a few demos with it, and I had suggested to the executives at ZeniMax that we were just preparing to do the Doom 3 BFG edition, which was our console re-release of Doom 3, set up to run 60 frames per second. And that was going to be a tough sell. It's an 8-year-old game at that when it was going to be released. That how do you get people caring about that and excited enough to write about it? And my pitch was, well, this work I'm doing, let me do stereoscopic 3D TV support. I'm not a big 3D TV fan, but it's a buzzword, and you can make an interesting demo for it there. And then let me do a virtual reality version for this, because even though we're not going to ship this, but it will be something that the press will see it and they'll talk about it. And this was my pitch. And I said that this will be worthwhile. I've been tinkering around with this. Let me just, on the clock, spend a couple more weeks tidying this stuff up and working on this, and we'll have something that will pay for itself in greater promotion for the Doom 3 BFG edition. So that was the plan, and we went through. I had, at that point, 3 head-mounted displays. I had one chintzy one that I had bought from a company that I didn't like much at all. I had the Sony HMZ, which was nice display, terrible latency, somewhat better field of view. And I had this one that I had cobbled together myself out of these 120 hertz OLED micro display drivers that was, fabricated in Armadillo out of this bent sheet metal thing. That was an interesting contraption there. But at about that time, that was when I crossed paths with Palmer Luckey, who had been building his kind of homemade head-mounted display that he was calling the Rift. And we interacted on a bulletin board, a forum, an MTBS 3D forum, and I just told him, look, I'm going to E3 and I'm going to be demoing Doom 3 that I've converted to work in virtual reality. I've got this low latency position tracking and all this stuff. Would you like me to take a look at your head-mounted display? And he just promptly mailed off his only working prototype to me. No APA, no promise of return or anything. He just sent it to me, and when he got it, it looked like a small shoebox with some lenses on the front, a little nose cut out there, and some cables coming out of it. And wrong voltages, lots of problems with different things, but the huge difference was all of these other displays were 25, 35, maybe 45 degree field of view. But with the Rift, big old lenses, you could put it all the way up to your face and you would have a 90 degree field of view. And at that point, after I worked out the ability to distortion correct for these, there's a lot of funny things in the Oculus origin story on this, where the lenses were from some pocket magnifying, lit magnifying thing that you could find at a hobby store, and they were just literally popped out of these magnifying glasses. There were the lenses that were placed on there, figuring out the right distance to put the screen away from it. And that's all it was. It was a box. You could hold it up to your face. So when I got it, I took off the sensor that I had on the other one, I hot glued it onto the Rift, I took a ski goggle strap and I duct taped it to the back of it. And this was the box that I showed at E3. And I showed it to the people at the end. It was interesting, I got a message from one of the programmers that invented it at the time, and he was saying how he's always going to remember that. The hot glue, the duct tape, he's like, I was there, man. I was there when it started. And there was this sense there that, yeah, this is something, And the response at E3 was, was amazing. Where we got a lot of people. This is when the Wii U's big introduction. Nintendo certainly hoped it would be their E3, and we had people saying that this duct tape and hot glue shoebox thing was the most exciting thing that they saw at E3. And after that, out of the historic arc of Oculus with the Kickstarter raising millions of dollars, going out, getting great people on board, starting the company, that was fantastic what happened. And at that point, I'm still at id, and I'm still saying I want all of our games I want to make Rage VR, I want to ship the Doom 3 VR stuff, I want Wolfenstein: The New Order to be VR, and all of these things that have any of the technology that I touch, I want to make in VR. And we had the proof at that time that it was worth it. The press that we got at E3 for doing the VR thing was absolutely worth it. I could justify it. But unfortunately, ZeniMax did not reach any kind of agreement with Oculus. Oculus was taking off, it was getting all this press, and it just didn't work out. So at that point, my contract was just about done. I gave up VR for 6 months or something. They didn't want me working on it anymore. But when my contract was over, it was like, I am going to do something on VR here. I don't want this to be like mobile or like free to play or one of these things where this became a huge deal and we squandered it, we dropped the ball. I think this is important, I'm doing it. At the time, I thought that I was still going to remain like a technical advisor at the end, and at that time it's like, okay, rocket science, Armadillo Aerospace, id Software, Oculus, it was clearly far too much, and it did all sort of simplify down to I'm exclusively focused on virtual reality stuff at this point, because I do think it's absolutely the most exciting thing to be working on in technology. I mean, I can sit here now with a straight face and give some of those vision statements that people were making 20 years ago. They were idiots saying it 20 years ago. It wasn't there right now, but it really is happening now. And I do think that this can change a lot of things. When we see there's 1 billion people that have a smartphone now, and that's a device that didn't exist 6 or 7 years ago. I do see a world 10 years from now where there may be hundreds of millions or 1 billion people that have a head-mounted display, because it can do things that you can't do with other devices. You can create a new world around you where you can have the prosaic things where we're going to have 4K resolutions in a few years where you can have virtual desktops, and instead of having 3 giant monitors in front of you, you can carry your virtual reality device around and do it wherever you're at and have a full workspace there. You can build environments that are amazing just to be in. Aside from all the interactivity stuff, so much of what people do, all of architecture and art, so much of this is about aesthetics that can be replicated infinitely in the virtual world, where instead of having to have the house that the billionaire owns that has the wonderful view, these are things that you can see in the pixelated messes of what you've got today. You can still see the glimmer of what's going to be possible, because there are technical freight trains that are pulling us on mobile devices here. What's going on with mobile displays, mobile processing? These are things that have tens of billions of dollars of work going into them constantly that are making them better, and it feeds directly into what we're going to be able to use for virtual reality. We are going to be able to make compelling devices here. Now, the people that have seen what we've got right now, the Rift DK1, this is one of these amazing engineering things that's really interesting, where the DK1, we actually had to stop selling it because the displays are no longer made. This is something that's surprising to think about, how the Rift, as it's shipped, could have been made 5 years earlier. So much that happens in technology happens as soon as it's possible. As soon as something is possible, there might be 5 companies trying to do things. And like one of the interesting examples, the personal examples about that was the patent situation that I got into with Creative Labs over stencil shadow bumpers, the whole Carmack reverse technique there. I was real proud of figuring that out as soon as I had something with stencil bumpers, and I said, I'm going to go do shadows. But somebody else had exactly the same idea, did exactly the same thing 2 months before I did. And that's common. That as soon as you get a capability, multiple people, smart people set upon a task, they figure out the same solutions. It happens all the time. So it was kind of amazing to think that the display and the sensor that basically is all that the Rift DK1 is, those were sitting on the shelf, and anyone could have put them together years ago. I mean, maybe it was a case of the creators left 20 years ago from the catastrophically bad VR companies had just poisoned the idea, so nobody was even looking that direction. But that's something that I'm still internalizing is, I wonder, it makes me want to trawl through journals from 20 years ago and see how many other great ideas there were that just didn't find their niche at the time, but are relevant now. That so many things do happen the instant they're possible, but there's probably huge fields of ideas out there that are great and ready to be reapplied now. Somebody just needs to dust off the old ideas and kind of get to work on them. So there are still tons of challenges that are going on in VR, but they're exciting challenges. They're things that, I had commented that when I was building these head-mounted displays and making this stuff work, I felt more like myself than I had in a long time. This was, there's virtue in calm and conservative engineering and just making something better. Most of the value in the world comes from those incremental steps. It comes from taking something that's good that people like and making it a little bit better. Most of the value in the world is like that. But pioneering is exciting. It's exciting to be out there and say, we don't know what the right thing to do is. We might be going in completely the wrong direction. And the old joke about the pioneers are they're the ones with the arrows in their back, but it is exciting. It's when you don't know what the right thing to do is, to say, well, we're going to try this, and we'll try 3 things and see which one works out best. There's whole new fields to be done in software and hardware research that we're doing. We think we've got a pretty good handle on a lot of the display side of things, but there's whole new realms in haptics, different I/O devices that we'll be using, things that can be done there, and they're going to have markets. There's going to be millions of these things. And it's exciting as a hardware developer, it's exciting as a software developer. There's all these challenges. There's the great aspect of, yes, I can dust off some of these hardcore optimization skills that aren't even really relevant to modern gaming, because modern gaming, you've got an abundance of resources and it's creativity limited. So that the hardcore low-level optimizer does not have the same position that they would have had 10 years ago, because it's just less important. It's creativity driven and gated now. So it's great to be able to take some of those skills and apply it to a platform where, no, we actually care about, I want to go from 20 milliseconds to 5 milliseconds of latency on these things. There's this stuff that requires interaction with system services, changes in the hardware, the way we approach the different things, the brand new stuff we need to build. It's all just terribly exciting. There's so many things to be working on here. I hope that we can go on longer, because I barely even got to the topic of building multiverses and things here. Now that we're up to the present day, we have in many ways, I am aggressively practical, especially with Oculus, where until recently, Oculus was a startup. And startups have to be very, very focused about shipping a product that does something that customers are going to value enough to pay you for. And yes, we've raised a lot of money. There was no worry about funding. There was this sense that we probably could raise as much money as we wanted. But I was still taking the tack that, no, you need to pay attention to what we can do X number of months from now, not what it's going to look like 5 years from now. I know, I probably rubbed a few people the wrong way about that, where it's just this almost annoying practicality of, okay, I know what we can do in a reasonable amount of time, and I'm probably still wrong. I've still got that programmer misestimation going on, but I know for sure what we can't do. There are some grand visions that are not going to make it in time for shipping, and we should not be working on those. But in the Facebook acquisition, which really was this whirlwind thing where I spent a day with Mark Zuckerberg, and then the next week found out he was buying Oculus. That was a startling. We knew there was interest from before that, so it's not like it came absolutely out of the blue, but it happened really, really fast. But that changes things in the way the engineering tasks that we want to work on, because well, as a startup, you say you focus on the next project that you're doing. That's the most important thing in your world. It's okay to incur technical debt and to do things that you wouldn't be doing if you were engineering for a decade from now. But Facebook cares about the decade from now. They're not buying Oculus for what we're going to ship on the PC this year, next year. They are looking at the long-term period. They want to see 100 million people in VR or 1 billion people in VR. So that means we do need to start thinking about the old dream. What is cyberspace going to be like? How are we going to build a metaverse? What are the rules of that? And one of the reasons that's been almost a live rail for me is that is it's almost the ideal topic to bring out the architecture astronaut and engineers, where the people that want to step so far back from the nuts and bolts of the problem that all they're thinking about is this grand vision of how the architecture of this is going to be. And the metaverse is the ultimate, it's the ultimate candy for the architecture astronaut, because we're defining the whole, it's the whole new world, man. How we can do anything we want, and I fear that so much, because it's easy to make very, very bad decisions like that. I much more prefer to concentrate on what are we doing this month, this year, what's the next thing that's the step that will lead us to that. But we probably do need to be focusing on some of the big pictures there. And it's funny, you'd think that people thought about this stuff 20 years ago, and there are books that people have written about this. I've got several proceedings of academic conferences talking about all of this. But I don't think there's anything close to a consensus for what people even really want. We have these visions of Snow Crash and the Matrix and this kind of uniform, universal world that can turn into anything that we want. But the most successful things that people have done in that vein have been massively multiplayer online games. And there are the danger of overgenerality. You have projects like Second Life, which is one of those things that's in theory so interesting, and in practice, I've tried 3 times to go and do something in Second Life, and I just can't make myself enjoy it. While the games, they take it as their job is to entertain you. You take people's money in exchange for entertaining them. So there's a clear path for things that you do there, but if you're making this kind of squishy metaverse architecture, you can always hope for emergent properties that will let rich things grow in the environment there, but I don't think that's any way to go about building it. You might succeed that way, but I think that the better path is to figure out the tactical, important things that you want to happen immediately, build the architecture for that, and then hope other things are going to be able to take advantage of it, rather than trying to say, but what about, and spinning these ideas and theoretical considerations that you might want to build into it, because there's just too many things fail that way. I'm steeling myself for that battle kind of over the coming 6 months to kind of keep things practical, because you can imagine this on a number of levels, where you could imagine a cyberspace infrastructure that was completely static media, that was not interactive at all, and it would still have value. It's not what anybody's thinking in their mind when they think cyberspace cowboys and all of this stuff, but even if you did just have a wonderful way to share static media, in many ways, that's of course what the web is. We have an interactive layer layered on top of it, but when people are spending hours and hours reading things, looking at pictures, or consuming movies and different things, these are largely static elements. And you could do a static-ish cyberspace that's updatable in different ways. Levels beyond that, you have something that has a functional level of presentation, where instead of being static, you have things that can animate and can do presentation aspects. You can do your particles and your weather and your moving sky and all of these things that adds another layer of, wow, this is really neat here, this is good to look at. But everybody envisions getting into multiplayer interactive. Another layer before that would just be single user interactive, where you have the responsive things that change the world in response to your actions. But everybody wants to imagine the world with the crowds of avatars in there doing the different things, interacting all together. And as anyone that's been through game development a few times go, there's just huge buckets of worms that you get when you go into keeping network play consistent. And people keep wanting to reach for the hardest problem, where everybody thinks cyberspace, well, it means it's got to be an open world cyberspace. It's got to be on-the-fly dynamic streaming, infinite horizon, pulling everything in, infinite number of people, all of these things, because that's the vision, that's where we want it to be. But we don't need to do that first. And trying to do it first is just going to result in failure, or it's going to result in something that that doesn't look anywhere near as good as as it should, or perform as good. So I am focusing on trying to do these more tactical things, but looking at them with an eye to how do we generalize this? How do we wind up letting this be used by more and more people? But even at the basic engineering level, there's the real question. So what's different between a game engine and cyberspace? Does Unity 3D become cyberspace in some way by grafting things onto a game engine? Or do you graft game components onto web architectures and infrastructures for that? There's important questions about how, okay, we need some way to be able to script interactions with it. It's not going to be a binary blob. Arguments could be made that I will fight strongly against that it should be JavaScript. It's the most popular programming language in the world. It does all these magical things on the web, but I think most people would look back and say that probably was not optimal, and we have opportunities to, to do things differently. A good argument could be made for C#, for the .NET framework. Unity 3D does a lot of really good things. Having a memory safe language, I think, is really important. But an argument could be made that should be native client, that the Google technology that lets you run essentially dynamically compiled native code and run C++ and everything. From a performance standpoint, that would be the best of the options, but I really do think that there's this strong urge that we need to get past the memory unsafe languages of the C and C++, and it's kind of sad seeing the way it's played out in the industry where Google starts off with Android saying it's all Java. People are going to write applications in Java. But they get basically clubbed into supporting the native development kit. I mean, certainly anybody doing serious high-performance stuff, if you've got an iOS application running native, you're not going to have a Java version on Android. So the native code gets pulled back into it. And it brings along with it all of the buffer overflows and segmentation faults and all of the stuff that the baggage of a language that's 40 years old in many ways that we're still dragging along with us. And I care deeply about the software quality and the things that we can do with the analysis, but performance is also really important. But you get to that point, you say, well, if you had twice as much performance, would you program in a memory-safe language? And a lot of people would say, sure, but then 18 months later, you've got twice as much performance, and there's some new reason why they still don't want to make that step to it. And I'm going through all of this right now, where sometimes I have Eclipse, Mono Develop, and Visual Studio all open at one time, writing in C++, C#, and Java. You see the pros and cons of the different things, and it's not clear to me exactly which direction even I personally want to go. I want higher quality software, but I'm also caring about platforms where we don't have performance running out every year. We really do still have to care about how we manage our code and our performance issues. And we've got the cases of the issues with consistency of frame rate that really argue against all the garbage collected languages. But maybe we can resolve that with asynchronous time warp running in another thread. And there are all of these exciting and interesting engineering questions to be going over. And it's only really, literally the last month since the Facebook deal that I've even allowed myself to start thinking about these, because I had walled it off in my mind. Like, don't think about that. More important, more pressing things. Concentrate on what matters right now. But just in the last several weeks, I've got an email that I've been kind of preparing to send out to the company, holding a lot of these thoughts about how stuff that we need to start thinking about. But it's not figured out yet. There was nobody that demonstrated what the right thing was 10 or 20 years ago. We just didn't have the hardware to resolve it. And all the successes really have come in gaming, and that's where we're going to draw a lot of the inspiration from. But there's still this feeling that everybody has that it should be something more than the game world, that there's something beyond that. But we still don't really know, and we're not sure who's going to wind up coming up with exactly the right answer. So I think we've already overrun some, but I can take questions until they kick us out. All right.
So you talked about how Oculus started with these, not just low-hanging fruit, but fruits already sitting on the ground running, right? And you talk about presence, and I thought the Valve room and that stuff was really incredible until I started walking around, right? And so I still lack locomotion and haptics and stuff. So are there, so it's a two-part question. First, is there an uncanny valley thing where we started getting so good at the visual stuff, but then these other things now become even more overtly absent? And then second, do you believe that there are low-hanging fruit on those fronts?
Yeah, I think audio is one of the low-hanging fruits right now, where as long-suffering audio guys know, audio has always gotten the short end of the stick in game development, because and as one of the people that gives them the short end of the stick sometimes.
Thank you for changing.
Yeah, it's been a justified call, because in the course of all those game engines that I've done, we've had two separate cases where we said, we're going to get serious about audio, get the DSP books, work on all the headlet and other transfer functions, and do all of this stuff. And you get it in there, it just doesn't make enough of a difference in the game. Because, for one thing, if you're doing an HRTF and somebody's got earphones on, it's wrong as soon as they're moving their head. So it's only right if they're just looking straight at it. And again, we've literally gone through this a few times in the gaming, and it never made sense. So games always wind up mix lots of channels, and it's just dumb mixing. But with head tracking, I think audio HRTFs come into their own, and literally like this last week I've been doing work on that, and it's exciting to have that sense of everybody's had the little demo where you close your eyes and you keep your head still and you hear the sounds compellingly moving around you that have been set up for that. But when you can get that sense of all presence, where you've got the sound emitters and it's responding in this time, and this is one of the things I'm still working out is, we know that the threshold for reasonable presence on visuals is 20 milliseconds or less. And there's additional thresholds below that, but you really got to be around 20 to get that sense of presence. I'm trying to find out now where that is on audio. Like one of the systems I'm working on has a crazy bad amount of latency, and it clearly is not a sense of presence, where stationary head moving sound sources works great, but moving your head around is that whole sense of pulling the world with you like you would have with laggy visuals. So one of my tasks that I'm working on right now is twisting some arms to get basically, I want to map the DMA buffers for the audio in my address space so I can go ahead and schedule as close to it as possible. Because this is how terrible things happen with latency. And the audio is a perfect example of this, where the way the hardware works, you've got a DMA engine, it just reads a block of memory, feeds it to a DAC, and it moves the speaker. So it's reading from a block of memory, making sound. Now, that's fine if you're writing to that block of memory, but as soon as you've got an operating system that's going to virtualize and mix multiple applications, you layer a mixer on top of that. So the hardware reading through this buffer, another layer says, okay, all you applications can feed this audio into me, I'll adjust the volume, I'll mix him, I'll mute him when he's not doing that, and I will feed it into there. But then you've got a process which needs to be scheduled by the scheduler, and that may or may not come on exactly where you want, because very few schedulers right now use the proper real-time semantics. So you find out, and this happens directly in Android and lots of other platforms where, oh, we might be 20 milliseconds before we get called. So instead of a 10 millisecond buffer, we need 3 buffers. So we'll push up 3 buffers. So even if it takes us 25 milliseconds to get scheduled again, I can push that in. 30 milliseconds of latency, okay, it's not great, but it's all right. But then what happens is somebody layers another mixing API on top of that one, and then you've got another thread which needs to get scheduled and says, oh, if I'm only scheduled every 30 milliseconds, I better have 3 times the amount of buffers there. And then all of a sudden you might get 150 milliseconds of latency, which is, it's an astounding number when you consider how fast the processors are going, all the things that we can be doing, that it's taking these human perceptible amount of time for something, for me to say, click the speaker here, and it's actually come out there. You know, contrasting that with something like network switches are pretty awesome in a lot of their implementation, where that's an engineering discipline that understands some things about latency. It's amazing to me that I can send packets to other continents faster than I can get clicks out of my damn speaker. It's slow. So that's, but I am working audio right now, because I do think now's the time that audio, we've got the processor resources to do that, and I think it's going to make a difference. But there's questions even there, like if you've got a good head-mounted display will completely block the light out, you don't see any of the world. But very few people are in a situation where if you've got earbuds or something like that, it blocks out the rest of the world. So you've still got, you know, there's oral cues here going on that even if I had earbuds in, I would still have the reference of the room giving me the sense of the head moving around. So I'm kind of curious where that breaks down with, I want to try testing stuff in like in a professional audio room there to see if you tell more or less the difference of lag and latency. So I'm curious to find out, is 20 milliseconds the gold number for audio, or do we need to go lower? But if I can get the DMA buffers mapped in, I'm going to be at 2 milliseconds or so, and that'll be, you know, I want to go, our sensor updates 500 or 1,000 times a second right now, and I want to be able to go update video output and audio output exactly every time we get a new sensor and blend over one. So we've got a lot more that we can do. We've got stuff that we can show at 20 milliseconds, but we've had various internal demos that are down at 3 to 5 milliseconds for some things. But it's funny when you get down to those levels, it's hard to tell exactly what the limiting factors are, because you can look at some of this and say, is the, when I'm shaking my head around looking at something, is the thing that I'm noticing a product of the distortion correction on the lenses, actual latency going on here, or something else in it? And it's funny where I spent some time, I've spent a couple of days sometimes where I'm just shaking my head, looking at something, and I've got a head-mounted display on, and so this is another thing where the old-timey virtual reality headsets, you would see people that use them, they would do this very slow looking around because they often had 100, 200 milliseconds of latency. And you do this and the whole world goes around you like that. But if you just move very slowly, you could get this, some sense of what you want. With the Rift, the Doom 3 code at least was at about 40 to 50 milliseconds. Most of the demos people have ever seen on the Oculus now are higher than that, it's more like 60 milliseconds, because they don't hit all the things necessary to do that. And you can still very easily see, just turning your head, there's this subtle little lag. The current stuff we're doing with OLED displays and time warp are under 20 milliseconds. And when you're moving your head around, it feels like, I would do this rolling head thing and it would feel like you're looking through a cutout into a world and it felt stable. But at 20 milliseconds, if you rattle the HMD on your head, if you're actually shaking it so the whole thing is actually kind of sliding on your head, at that point it's clear that it's a picture that's still moving around. That effect is faster than 20 milliseconds. When you get down to like 5 milliseconds, at that point, you can shake it on your head, and it still feels like you're looking through a window. Or conversely, like you tap on the side of it and do some of these other things that even at 20 milliseconds show up. So I'm interested to find out what the realm of interactions for audio are like that, but that's absolutely something that we can do. 4K resolutions and other things are going to be harder, but audio we can do now.
Yeah, what do you think the future and role of eye tracking is in virtual reality?
So there's an interesting aspect about that where I'm talking about HRTFs for audio. So one of the interesting things, actually, wait, is there a marker anywhere?
Yeah, there's markers.
So if you've got a head with ears on it, the way the audio processing works is you may have a sound source here, and it goes over and winds up. Some of it goes directly to the ear, but then a lot of it goes and interacts with the head. So it winds up traveling through the bone, reflecting off of other things, and coming around to ear here. So a signal here gets some direct amount here, and various transmissive and reflective amounts in the other ear. So what's interesting about that is, if you think about audio in a home theater setup or a theater setup where you may have 7.1 surround sound, what you're doing at that point is you're actually simulating the entire audio space around the listener. So you built an audio field of everything, which takes these full 7 channels, and it's not even necessarily perfect where people are listening in different areas or if you moved around, while an HRTF audio function is simulating sound as it's already entered your ear. So you're making 2 channels there. Instead of building sound in the entire world around it, you're just working out what would be coming to your ear if it had been there. Now that's an important contrast to what we have with the display side of things, where when you've got a head-mounted display, you've got lenses here, they are making a light field, which is going out in all directions. If your eyeball is there to intercept it, great, but it's sending out stuff which is not where your eye is focusing, your foveal region. 90% of the pixels that you're drawing there are not going to good use. In the audio case, you simulated everything out, and every bit that you're pushing out actually has some direct acoustic perceptual value to it. Unfortunately, on the head-mounted display side, so much of what we do is completely wasted. And we've got this case where, as we're taking these crazy paths to 4K resolutions, one of the interesting things is if you work on big monitors and you've got a 30-inch monitor or multiple display, everybody's had that case of, where's my mouse cursor? You're moving hundreds of pixels, jumping all over the screen, tagging thousands of pixels as they move around, and you don't perceive it at all, which is the sense that those are largely wasted pixels. If we had perfect gaze tracking, it would be wonderful for us to be able, well, what you obviously want ideally is, at the top of the line, you want direct neural stimulation. One step below that, if you have the ability to do like laser retinal scanning, to be able to scan directly onto the retina at different resolutions in different places. I was super excited for years about direct retinal projection until I learned some of the aspects about it where you can't use a single projector to stand interestingly on there because the lens basically takes all of that back out and turns it back down into a point. You need optical spreaders. And you wind up not with a cool tiny little thing that I was imagining projecting into your eye, but an optical system that winds up looking like something that you could have done with a larger scale display. It winds up not being nearly as interesting. So the optics are a separate problem where maybe in an ideal world when you get to contact lens displays, and there's some darker projects and stuff going on that people are thinking about that level of stuff where you could project directly on it and it moves with it. At that point it would be like the earphone situation where if we knew that we could move something with the actual eyeball as it moves, we know foveal regions right here, rasterize this at 10 times the resolution, lower resolution out here, that would be really great. It's somewhat less valuable when you still have an actual lens and a display back there because you're going to have the full resolution anyway. Your eye's focus region can move by plus or minus 25 degrees or so. You can cover a pretty wide range of areas and it's got a focus of a couple tens of degrees. So our display that's 90-degree field of view nominally, you can move around and you can focus and steer your attention at just about any part of it. So all the resolution needs to be there. There's no way to kind of like magically move the resolution where we want it. So all the focus, if we had perfect gaze tracking right now, we could render lower resolution imagery in most of the screen. We've done some tests like this where even without gaze tracking, it works kind of well to render a low-res version that covers the entire 90 degrees, and then another version that's maybe the same number of pixels in the center 30 degrees. And one of the reasons that works out interestingly is because of the way the distortion on the lenses work, your imagery on here, the central region, you get high resolution, and it fades off to lower and lower resolution. Like if you look at it as it comes out of the view, if you didn't have distortion correction on, it winds up coming out as kind of a pincushion like this, where the pixels get jammed together and you waste a lot of pixels out here where you've only got the full fidelity that you want in the middle. So it actually works out fairly well to render a high-res insert and a lower res for the rest of it. If you had real gaze tracking, you could move that around and do even better. Surprisingly, it's really not noticeable dropping that. But the problem with that is it already taxes a lot of applications to be rendering a stereoscopic view with 2 views. Asking them to render 4 views, you wind up becoming CPU bound, even if it saves you GPU resources by not rendering as many pixels. Now there's things that we can do with, there's some extensions and new geometry shaders, things to be able to let one command stream generate 4 views. And I think that as we move to higher resolution, certainly by the time we're at 4K resolutions, we will have 4K displays, and we won't have 4 times the GPU power, I don't think. I don't think the GPU is going to scale quite as fast as the resolution. So we may wind up being forced to do something like that as we take a few steps forward. But we are still limited then by the optics and not having necessarily the clearest. It's always going to be more distorted, more correctly on some of the edges. But it would help. And there's also some potential things that we could do. I mean, it would be neat just to be able, when you see another avatar in virtual reality, to instead of just having a programmatic blink rate or something on there, to be able to actually track really where their eyes are going. Right now, we fake stuff where if you've got 2 avatars and they're looking at each other, you assume that they're going to be kind of locking eyes, and you move your head side to side and it counter rotates the eyes. But it'd be great to have that be a real sensor value. But it's as far as we know, we look at it a lot, and I think we did just buy a good gaze tracker at Oculus headquarters, but we don't think that that's real near term on the PC.
My group actually does have perfect gaze tracking, and it's ready to ship.
What does?
I'm working for a company called iFluence.
Have you talked to anybody yet in Irvine?
I don't believe so, actually.
Okay, yeah, just an email. I mean, it's a topic that we carry. It's on our list. It's not at the top of our list because there's not things that we, there's not things that are currently gated by gaze tracking. But I'm sure we would find some useful use for it. And as with so many things, sensors are sprouting up everywhere. We'll use all the different bits that we can get.
In your review of early VR, I don't believe you mentioned the pilot flight training simulators where you've got wide field of view, high resolution, tied kinematically to a Stewart platform. So how does that fit in, and would Oculus consider developing a low-cost Stewart platform?
Yeah, so I always in my head, and it's not, I probably should have clarified this, but the larger field of simulation, I always consider VR to be goggles and maybe gloves, you know, the early 90s stuff where it was a completely different crowd of implementers. The people that did the simulations, those were the serious people that did serious work and, you know, looked down on the gaming and everything. But I didn't lump them into the same crowd as the kind of goggles and gloves group. Oculus is, we know that we are in the process of murdering the entire head-mounted display industry, and that there's a lot of the government workers that have done the ARPA contracts and everything that are going to be, their companies are going to go bankrupt. And that's just kind of one of that's the creative destruction thing going on. But we are somewhat intentionally not engaging much with the serious simulation world, with the military sim stuff. I expect a lot of them will be adapting Oculus hardware, but we are focusing on we want the 100 million users, not the 1,000 customers, and it is just a matter of focus. I mean, we wish them all the best, and we'll be happy to sell them hardware at 1% of what they were paying for different things, but we're not going to consciously target them. Yeah.
Okay, so given that where we're at with real-time graphics, and given that we're basically on the cusp of a major explosion of geometric complexity with world detail, how do you, what are your thoughts on keeping art content costs down?
So, as I was building the whole mega texture pipeline for Tech 5, it was obvious to me that the next step would be like a mega geometry, where you would virtualize everything and everything would be maybe voxelized at some level. I mean, as far as voxelometry worked before that. And that seemed the obvious next step. But I'm actually, even before finishing Rage, it was clear that it was so hard building that pipeline. And the other thing that really kind of caught us by surprise is that the game industry now, it's an industry with people that have career tracks and skill sets, and people want their skill sets to be portable between companies. And it was really problematic for us that we had this oddball technology that could let some artists, it was a canvas that they never had before, they could build things they couldn't build anywhere else, but it wasn't things that people already understood. It had different trade-offs, and that hurt us a lot more than I would have guessed at the beginning, where there's a large tribe of people that can migrate from company to company and say, I'm an Unreal developer, I'm a Unity developer, and you can just drop them in a seat and get them working, and they can add value to a company. And if you've got an oddball pipeline that's really different, that hurts you in some level. So I'm not nearly as bullish as I used to be on geometric explosion. And in many ways, the one aspect in geometric content creation, I think that there is a huge amount going on in real-world scanning, and I think that's going to dovetail a lot with virtual reality, where direct scanning of the world, we've got a lot of awesome things in panoramic photos and panoramic video now. And one of my triumphs in the last 6 months has been championing 60 frames per second panoramic video capture, and that looks really good, but it still doesn't have the depth, and we will be moving towards eventually having depth laser scan entire scenes and then animate them. And that will be steps down the road for it, where you will have billions of data points. But the hand generation of it, it still seems that it's possible in gaming since everything's built high poly. But another thing I was kind of surprised at when I got down to the nitty-gritty with the artists is how many tricks and smoke and mirrors things that they're still doing from the high poly to the low poly models, where back in my programmer corner, I was thinking, it's like, well, just use the high poly models that they already made. But there's manual steps in between all of that make it not quite that easy. And the other side of it that I came down to is, just like in some ways with the mega texture, it's not going to make that much of a difference. And in fact, it's going to make less of a difference than the texture in there. And there are going to be people that kill themselves building a mega geometry game engine, and no one's going to care. Yeah.
Just because I think it's a really cool, it's, I guess, a unique question. I think you're one of the few people that can answer. What kind of differences could you say you had to go through, or changes in how you thought about solving problems? From basically a software firm to now basically you're a hardware guy. Yeah.
So I really enjoyed the Armadillo Aerospace work about, and that primed me for being able to put some stuff together on the Oculus level. But it was very worthwhile as a software guy to go and and build physical things. Because there's something that I would really see from that is software people are used to being able to kind of do magic with our fingertips, and we can build these amazing castles of complexity, and getting down to the physical world and making custom reality obey you in the same way is something that I see a lot of ignorance on the software side for people who just do not comprehend how hard something you can sketch on a napkin can be to make function in physical reality. But it was a great learning experience for me. I mean, I enjoyed learning how to run a lathe and run a mill, write CNC code for it, do that, and the craftsmanship aspect of things where I still wound up reverting to my normal mean of being results focused and caring about the end, but brushing up against some of those other sort of styles of endeavor where, I do self-identify as an engineer first and foremost. An engineer is someone that tries to, make what you want with the resources you've got at your disposal. But there are all of these other enticing mindsets that you can have. Like craftsman is one of them. You can be a code craftsman and you can be a physical craftsman, but there's that sense of when you're cutting something on the lathe and you make that final extra polished pass, or you round off all of your edges. The mechanical aspect of that has a physicality to it, obviously, that you don't have in software. There's a lot of valuable things with trying to make things that should be simple but turn out not to be, and going through those battles and learning it. It gives me a much better, it lets me interact well with hardware people now. I miss not doing that. Now it again comes down to that focus thing where I realize I can't do everything. I can't split my time amongst 4 or 5 different things. On a weekly basis, at some point I will miss physically building things, and I wind up coming to some point where I realize I could just go build this right now and it could solve some problems, but it's going to take me, I think it'll take me a week, which means it'll take me 3, rebooting everything and getting it all going. So I'm staying away from it. But it was a valuable experience for me, and I don't regret it at all, the time that I spent on it. Yeah.
One of the big fears when the Facebook acquisition was launched was that Facebook was limiting the vision of what Oculus is set out to do. Do you have fears that they'll run?
So it's interesting where, I obviously can't, I'm not supposed to talk much about Facebook, and really I can't, because there's been almost no interaction at this point. Yes, and that's my reminder.
Next question.
Let me tell a funny anecdote at least about this. So I've been working on networking code recently, and it's been great fun for me on this, not just graphics, but doing audio and networking and all the different disciplines again, going through all of it. But so a couple weeks ago, I'm writing this this packet server thing that's running on an EC2 instance, and I'm sending VoIP packets up through it, and I realized to myself, wait, I'm passing everyone's control and voice information to some centrally located server. This is exactly what everyone is afraid is going to happen. So I will eventually do some NAT punch through things, so I don't need to go through and do all of that. But completely innocuous, innocent technical decision to make something work. And I just realized, okay, that's probably going to play the wrong way when certain people look at it that way. But I was I've been saying this publicly, where I think that the Facebook deal is important for VR, where Oculus as a company is, we do not have this wealth of IT infrastructure stuff, and we want this network multiplayer cyberspace world. This is the vision that we want to go to, and the company does not have the resources and the infrastructure and the people with the backgrounds to do that. I hugely respect the scale that Facebook operates at. You do not serve 1 billion people with penny IT infrastructure, and I'm not arrogant enough to think that it's easy, that you can just go do it. The comment is, yes, we're smart people, we can figure out how to do anything, but there will be a lot of bashing our heads into walls and making mistakes along the way. And already Oculus has, practically every major rollout we do, we botch something on the website or the server deployment stuff, and we learn each time and we get better, but it's fine when we've got 50,000 users, but if a product goes out and we have 500,000 or a couple million users, I just don't think we're prepared for that. I want to leverage Facebook's ability there. And there are aspects of it that there are lots of different directions that people think VR could or should go in. And Facebook is thinking a more inclusive vision. They want 1 billion people. I think that's the right vision. I support that direction. I support seeing what we can do with potentially lower end stuff. We want our crazy high-end stuff that people will spend $5,000 to build out the high-end PC gamer rigs, but we want to be able to support lower end things as well. So I mean, check back a year from now. We'll see how it goes. Yeah.
So I apologize in advance if these questions have been asked before. Rage was a game that performed impressively well on the consoles of 360, 6-year-old pieces of hardware. And this is a topic that's very interesting to me, especially after reading about stuff like the fast and burst square root algorithm. And I was just wondering, were there any creative methods that you used to get it to run as well as it did on those systems?
So it was I'm still really proud of how well Rage runs on the consoles. It was a huge amount of very hard work, and it was a battle that it was fought several times over the years. And you could at least make the argument that in the end, we love the way the game played, but some of the arguments against that would be that, well, would we have been able to ship it earlier if we had just punted it at a 30 frames per second game? We could have had more particles, more other stuff in there. So there was a set of trade-offs there, but I very consciously wanted it to be 60 frames per second because I thought that we had reached this point when I looked back at Doom 3 and said, we focused on the visual fidelity of all of this, and we made a slower paced game, and I thought we were past the knee of the curve in terms of the benefits we get out of graphics. And I thought that we had an interesting way with the mega texture to both advance the graphics, to be arguably the best looking game on the platform and the fastest. So it was an interesting technical niche that we could pick there. So in hindsight, it's possible it wasn't the right thing. I liked what we did, I liked what came out of it, but it was hard. I mean, there is a big difference between getting everything done in 16 milliseconds and 33 milliseconds. There's a lot of things that that you wind up saying, oh, this will just take a couple of milliseconds. And when you got 33 to dole out, you could do a lot of those different things, but when you've only got 16, you don't. But that was one of the unexpected benefits of it that we didn't think, where when you've got 33 milliseconds to dole out, you can have infinite arguments about what you're going to do, because you can do anything. You just can't do them all at once. You can do crazy graphics algorithms at 30 frames per second, but you can't do them all at once. At 60 frames per second, it allowed us to be very brusque. Nope, not going to do it. Can't fit in 16 milliseconds. Next question. And that was a positive. But there was a lot of low-level optimization. There was lots of SIMD optimization. There was lots of GPU scheduling. A ton of work in managing multi-core performance. It was just lots of hard engineering work through it. But it was the decision and the commitment to stick through it there was challenging, probably more so than I would have thought at the beginning, where when you're struggling up against there and wondering, is the PS3 going to be able to make it, which is a little bit slower than the 360, what are we giving up by doing this? Everybody wants their fancy particles. There were tough decisions to be made along there, but I'm still happy that we made it that way. I mean, if somebody could tell me for sure we could ship the game in half the time, I would have had 30 frames per second would have been fine for me, but I'm afraid we would have taken just as long, had a prettier game, and run at 30 frames per second, and I wouldn't have had something that I could look back on and say, I was really proud of the way that we had played.
So on the topic of simulator sickness, there's been some research for maybe the last decade or more into stimulating someone's vestibular system, or maybe even suppressing it with some pretty scary things like electrical currents, strong magnetic fields.
Yeah, Palmer's actually been involved in some of that work. And there's, yes, it sounds great how you can put a little electrical current through here and then you don't get signature. You can feel like you're accelerating in different directions. Wow, this would be great for VR, but there's some worry about scar tissue forming in parts of your
I'm just wondering if you think we'll ever see any serious push to do something like that, or will then less invasive things like low persistence, low latency video and audio, will those be enough to get rid of simulator?
What we want is direct neural stimulation. You want to plug into the matrix, and there's all these reasons why. The bandwidth would, things would be a ton faster if we were only stimulating the nerves that we actually needed to on there. It would be a great thing, and I was actually a little surprised at some of the stuff that's coming on like that, where I have nothing invested in that future. That's left to a completely different field of scientists and engineers to kind of work on. But I don't dismiss it at this point because there are some positive signs that things are going with people teasing out, especially on output. You know, there's like sensors that you can put on that can tell when your fingers are about to move. And the exciting thing about that is it can tell before your finger actually moves. It can be negative latency over what sensing something in the physical world can be. So there's exciting stuff with the direct neural analogs, but I think that external actuators are what we're going to be with for a while. The people there's a lot going on with different types of haptics and other research things. One of the kind of neat things is Oculus actually has a staff of PhDs now, where we've kind of got our research department and a lot of people paying attention to a bunch of different areas of academic research and different industrial fields. So we have a bunch of people that are not nose to the grindstone on the products making this stuff, but are paying attention, and they're supposed to be our bellwethers to let us know when something really important might be coming down the pipe a little bit ahead of time. We are just spinning up now a completely new R&D department in Seattle to be working on stuff that's not the next product, but stuff that may be a step further beyond that. So it's again great to have the resources to be doing that.
So one of the arguments that Mark Cuban makes against 3D TV is that you want to have your Super Bowl party and you don't want to be wearing dorky glasses. You could argue the same thing for LAN parties and VR there. How do you think VR is going to overcome the problem of just a bunch of people wanting to hang out?
Well, I think for one thing, the sense of presence that you can get is communal in VR. So you can have avatars, and that's one of the things that we're working on literally right now, day to day here, is figuring out what works well for getting people to be able to see other people and feel like they're there. So the hope is that it is not an isolating experience, and in fact, much less so than everybody staring into their cell phone somewhere. If everybody puts on their goggles and they're together in a more exciting virtual world, I think that's a positive thing, and I think we're actually going to get that. I mean, a lot of my focus now is on the networking aspect and what we can do forward, because that's going to be the novelty of VR. It really will be exciting. So I'm not very worried about it being the isolating experience that a lot of people worry about. I think that in many ways, cell phones and such have been a much more isolating form of entertainment than VR will be.
Yeah. Have you thought about enhancing the human body capabilities by, let's say you just say, I don't care about what my right leg does as far as this virtual world. Let me hook sensors to it and give myself 3 arms. And over time, a human will learn how to control the third arm just to go together. I don't know how much time that takes.
So some of the interesting things that, like in the dawn of VR in the 90s, you had a lot of people talking about things like, won't it be cool to be a squid, or something like that. And for the most part, the answer is no. It's better to be people inside the virtual world. What we can do in there is we can give the wealth of, we can make virtual goods that let people take the place of the wealth of a billionaire in reality. We can replicate in there. And while there will be things that people want you to go and be the crazy different thing, I think that most of what people are going to want to do in VR are do things that people do in reality, but that are either too expensive or too dangerous, or things that they choose not to do or are not allowed to do. But I think for the most part, people will still want to be people. I mean, not exclusively, but I think that will dominate the interactions. Yeah.
Do you think it's hard to quell kind of users' expectations? Because I know everybody says, oh, okay, we're going to be doing the same games we're doing, they're just going to be so immersive. And I've been a big supporter of VR and since the early Kickstarter. And I always try to tell people, if you did 30, 40 mile an hour parkour in real life, you'd get sick, right? I mean, so just doing it, even if we can replicate it perfectly.
There are significant real issues dealing with locomotion and sense of acceleration, where the primary thing the biggest thing that engenders the simulator sickness is when your eye says the world's doing something that your inner ear doesn't say. Which is why, if you've got everything else nailed, if you've got the distortion correction and the projections are exactly right, and the latency's low, the stationary experience, like the Valve room, you can be in there, you can look around, you can walk around, and it's great. It's really, really good. But even if you took that, that high-end piece of hardware, really the best piece of VR that anybody's ever put together, and you start circle straafing in it, you're still going to get sick because no matter how good that was, even if it was your infinite, perfect, direct retinal neural stimulation, you would still get sick because of the disconnect there. So kind of the mantra at Oculus now is comfortable experiences. We're talking about these things. But the honest truth is I am 100% confident there's going to be a whole generation of people that just grow up doing all the crazy things, with that, and don't worry at all. Because back in the old days, I mean, we had people that got sick with Doom and Quake, and nobody thinks people's like, oh, a first-person shooter, that's going to make everyone ill, because clearly it doesn't, but it was a problem at some point. So the sickness, the fundamental issue about locomotion there is a real issue, and there's some interesting experiments going on that, like one of the tests is something where you hold a button and you locomote as if you're riding a bicycle or something. So you turn like this and you turn in virtual reality. You can do some motion like that, and that seems to be fairly effective because if your brain thinks like I'm kind of doing this in one way, there's a little bit of acceleration cue that it can buy it. But these are things that everybody's going to be figuring all this out in the next couple of years, and it's going to take a couple of years, I think very much like it took a few years for touch to kind of find its legs on the mobile platform for how you do it other than being virtual thumbsticks there. And I think that probably right now nobody knows the right solution for locomotion in VR. But we know we can do a certain class of things where you're relatively stationary, you're seated, and awesome stuff happens around you. And that's a design dynamic or experience dynamic that nobody's really explored now because they haven't had to. But here we are in a situation where there's an important reason why new rules need to be examined, and that should be exciting for anyone in the design space where technology or reality is forcing you to re-examine kind of fundamental concepts from other mediums. Yeah.
If the current generation of display technology is like a screen with lenses on it, what do you think is the next big step for display in VR?
So there are huge advantages that we have by piggybacking on the mobile infrastructure. So what I really want is a compound curve display where right now we've got lenses that are kind of like this, and we've got a display up here. And so you've got all of these different focus issues of as the light rays wind up going there and focusing out to a roughly straight thing. It's different on the different parts. You get different amounts of convergence and divergence based on where it hits that. And we adjust for all of this by having funny profiles on there, picking kind of a sweet spot and different things. But what I really, really want is an OLED display that has a compound curve that matches the curve of the lens. So you're back to a simple spherical section on the lens instead of a complex A-sphere. And you have everything equally in focus, equally distorted. There would be some real value to that. But people are making flexible OLEDs now. They show up at CES, single-fold flexible ones. I want to get one and to see if I can heat press it down into a compound curve or something to try some of this stuff. But that's one of those things that, again, is potentially the advantage of being acquired by a Titan is that custom hardware is not completely out of the question now. You don't want to do the R&D on all of that, but it becomes possible to conceive of doing a display that might have something like that that would make the display significantly better. Okay. Thank you, everyone.
Oh, just one quick question. You guys have shown a big spotlight on VR now, so obviously there's going to be a lot of competition, a lot of people trying to get things in market before you. I mean, is there concern within the Oculus about how that affects your timelines to getting a consumer device out? Because I would imagine that the first one that gets out there with some money behind it is going to form perceptions to the consumers of what VR is.
So to some degree, I was pretty surprised that we didn't get a Rift competitor earlier because the first dev kit, DK1, really is not that sophisticated. It's an LCD screen, a couple lenses, some plastic, and a ski mask now there. It's a little bit different with DK2. The vision hardware, the vision software, and the hardware that goes into tracking, that's a more significant barrier to entry. I think that there are people working on the different things that have some or all of the different pieces to put together. Sony can put together something good, although right now I do kind of look at it as that they're bringing an LCD to an OLED fight, which may not go well for them. But they have smart people that understand the issues and problems there. They're probably going to do something well. You know, I had conversations with Sony before the whole Oculus thing started, and I actually suggested they try to hire Palmer early on, so I wish them well with all of it. And honestly, at this point, I don't think that it would hurt us, even if they were hugely successful on the PlayStation. You know, we are focusing on a broader market, educating people on VR. You can absolutely do a good job on the PS4. It's powerful enough to do a solid experience with it. In terms of other people now, probably a lot of them feel I'm sure there are people that have been working, spawning companies that are attempting to compete with Oculus, and the Facebook acquisition was probably a little bit of a kick in the stomach for them on that, where we've already raised a ton of money and have the ability to have a lot of these things going on. It's great to have our PhD squad and our R&D team going up there, all this stuff, and Facebook is probably raising that to another level where there's a greater barrier to competition. But I've always been much more excited about the engineering side of things, and in the gaming industry, I was happy to see other people do great things and say that I'm some distant ancestor of a lot of the magical things that other people are doing. I'm an entrepreneur only incidental to being an engineer.
That's a question about Dallas. So are y'all going to start up a bigger area in here, or is it just because you're down here?
We've got a half dozen people here now, and we'll be hiring a few more. It's unclear how big we'll wind up getting here. There's questions about how much content development we want to do. Right now, it's all platform-based, and a lot of it's on the stuff that we can't talk about right now. We're working on a secret project. But it'll be growing, but probably not huge. The bulk of the people it's growing really fast.
Oculus is always looking for good people. So
yeah. Yeah, but the Oculus it's amazing the talent that we've been able to attract recently on this. I mean, I'm so psyched getting Michael Abrash and some of the other Valve guys on board there. We're pulling people from a lot of different companies that are very high-end people, and it's good to be able to have that level of talent.
Was there any bad blood between you and Valve since like butchered a lot of their team, or since they're not really doing hardware, are they kind of okay giving up?
So I haven't talked to Gabe since any of this stuff happened. I don't, they were never going to make a headset. That was not what they were doing. I was never really quite sure what they were doing there. I mean, it was great that they hired a bunch of brilliant people and they did this great R&D, and I owe them really a big debt because the low persistence work that Valve did, that was not on my radar. And this is so wonderful to me to have, I know so much about so many aspects of this thing, to have something that I really wasn't paying attention to pop up and turn out to be a big deal. That's kind of a magical thing for me. And I just thought, well, we're going to get 120 hertz OLEDs, that'll be fast enough. And I wasn't considering the low persistence aspect. And it wasn't really until when Atman was talking about this, I made a couple trips up to Valve and talked with them about it. He was saying how important this was. And I was kind of like, I'm not sure that I buy it yet. I think that we'll be good without this. But they built it. The existence proof is always the best way to win an argument. It doesn't take long. You put it on, click the button. Yeah, that's way better. You were absolutely right. Win an argument in 1 second with an existence proof like that. So but the main thing that Valve wants is PC games. They want high-end PC games, and Valve would be very sad if Oculus became a console-only peripheral, because that would be completely contrary to what they want. But if VR brings new life into, or additional life into the PC space, I think Valve's going to be completely happy, because that's their platform there. How that interacts with Oculus, a lot of that still remains to be seen. But they're pushing their OpenVR or their Steam VR side of things. They've still got a bunch of smart people there. I don't think we hate each other. Yeah.
Have you tried Google Glass hardware for your VR as a substitute?
So, augmented reality it's an interesting topic, the way this goes. First of all, Google Glass was sold as a vision. Again, they did the whole hand-wavy thing about this is going to be awesome in the future, because everybody wants the glasses that put people's names over their heads, so you remember all of that. I mean, I dearly want that. That's of course not what Google Glass is. Google Glass is a little smartphone display that shows up on the side, and it's not even augmented reality. It's a wearable display, which is not all that exciting. I don't think that there's a huge win over that. There's some value, but over a watch or a phone, it's not huge. When you get to augmented reality over a wide field of view and you really can't add annotations to the world, that's going to be huge. And if you had asked me 2 years ago, I would have said augmented reality is going to be the many billion-dollar industry, and it's going to be much, much bigger than VR, which at the time I thought was going to be limited to entertainment aspects. But I've come around in the last, really after the high-resolution, low-persistence work, seeing that the VR headsets, even if you're not using them as VR, if you're using them just as virtual displays, are going to start displacing a lot of monitors, allowing people to work in a lot of areas. And I do now see immersive VR as something that can take place, at least at the tablet, where it maybe doesn't displace something else, but it's a new device that people want to use in new ways and can have that that scope. But the other thing is, AR, the way people want it, kind of Terminator vision, where you see the world and you see all the annotations on it, is actually much harder than immersive virtual reality. Because we're saying 20 milliseconds is pretty good for virtual reality. You want to get it down to 2, but even 2 milliseconds of lag in augmented reality is moving around. You're still seeing all the names kind of shift over people's heads. And the issue of how you have sunlight visible augmented reality, the fact that you can't dim anything out in focus, there's a lot of problems there that actually make it a harder problem. And I think that, and that was one thing that I was telling the Valve guys there. They started off on the AR focus, and I strongly made the case that, that's great, it's probably going to be huge, but we can do VR right now. And we can do it now, it's valuable, we should do it. We should do that. And I was happy that they pivoted off of the AR stuff and focused on that immersive side. All right.
Thank you very much, John, and thanks everyone for coming.